Good morning, everyone. My name is Payal, and I am the marketing manager for Mouser India. A very warm welcome to all of you, and thank you for joining us here in Bangalore. Today is a special one for us. After a fantastic opening in Pune, the seventh edition of the Mouser India Technical Roadshow now rolls to Bengaluru. This year's series opened in Pune, and over the coming few weeks, we will take the series to Chennai. But it all begins right here with you. When we first started this series, the idea was simple to create a space where innovators could come together, not just to learn, but to learn about the technologies, to exchange ideas, ask questions, and share the kind of real world experience that pushes design forward. Our very first roadshow was built around IoT. Back then, it was still a buzzword, just starting to shape the future. Since then, the series has grown to cover a much wider canvas, from rugged electronics and power management to AI, connectivity, and beyond. Today, alongside our partners, we are excited to carry that journey forward, bringing you the latest technologies, trends, and insights to help you turn your ideas into reality. So, thank you once again for being here. We have got a full day ahead, packed with technology talks, expert sessions, of course, the chance to make new connections and catch up with familiar faces. However, before we begin, a quick few notes. We would request everyone to please keep their phones on silent. We will have short breaks in between sessions, and lunch will be served at 2. And please do visit our partner booths during the break. There are some exciting demos waiting for you. We will hold all the questions for the Q&A at the end, so please keep them handy till then. And please do note all the presentations will be sent across to everyone here with us today. To kick things off, it's my pleasure to welcome Kevin Hess, SVP of Global Marketing, to take us through Mouser's journey, who we are, what we do, and how we are driving meaningful innovation across the electronics industry. Over to you, Kevin.
Good morning, everybody. I am Kevin Hess. I'm Senior Vice President of Global Marketing for Mouser Electronics. First, I'd like to thank everybody for taking part of their day to spend with us and learn a little bit about Mouser, but more important, learn about the technical information we're going to go over. Okay. So, if you'll give me time, I'd like to go over a little information, corporate information about Mouser and give you an idea of what type of business we are and how we go towards the market. So as you can see, we are the new product introduction leader when it comes to distribution globally. And we focus on new products because when it comes to engineers, it's important for you to have the latest technology in your hand quickly so you can move on to that next design. So where does Mouser play in the design cycle to the production cycle? We're actually part of everything. So if you look at the very beginning to when an engineer has a concept of the product they want to build, or maybe even a product they want to enhance, we're the perfect source when it comes to the latest technology. And then once you get to prototype, we are a distributor that will sell in broken pack quantities. You don't have to buy a whole pack. You don't have to buy a whole box or a whole carton. We will actually break pack for those engineering or small production quantities and get those to you within just a couple days. And then once you're into production, again, production is kind of a relative term because production for some people could be 5,000 pieces. Production for other people could be thousands or hundreds of thousands of pieces. So we can actually support everything from design into production depending on what your quantity of production is. This is a picture of our only warehouse that we have in the world. We are based in Dallas, Fort Worth, Texas in the United States. And everything that we ship globally ships from this one warehouse. And just to give you an idea of how big our warehouse is, it's well over 1 million square feet. And some of you may not be able to hear me, but I'm going to point out where our corporate office is, where our local sales office is, and everything else is actually warehouse space. So our corporate office actually is this portion of our campus here. Local sales office, which only handles the Americas, is here. Everything else you see is warehousing. And Mauser, over the last several years, we have been investing in automation in the warehouse because it's very important for us that once we get the order in the warehouse, it ships the same day globally. So we can't continue to have people be responsible for doubling our business. So we have invested millions of dollars into automation to allow us to process more orders quicker and get the shipments out same day. As I said, this is our only warehouse, and we are able to ship, it's approximately 25 to 30,000 orders a day out of this warehouse globally. Mauser.com. Oh, okay, thank you. Okay. So on Mauser.com, I'm not going to read through all of the metrics that you see up here, but I'll let you know that we have several different languages available on Mauser.com. You can buy in several different currencies on Mauser.com. And there are over 1.2 million products available to buy same day. And for us, especially when it comes to focusing on the design engineer and the buyers, we have the widest selection of electronic components in stock of any distributor in the world. So it's very important for us to be able to serve you to have those products on the shelf in your hand within just a few days. Through our web, there's about 78 to 80% of our transactions come through the website, but that only makes up about 62% of our sales. All the other sales are done through our branch offices that we have well over 28 throughout the world. So we allow customers to buy on the web if they prefer to buy on the web, but we also have local salespeople around the world understanding local cultures, understanding local customs and languages to help our customers. So about 62% of our business comes from the web, and then the rest of it comes from buyers and engineers who call our local sales branches daily. Something that's very exciting and important to us, if you'll look at your lower right-hand side, right now we have just a couple offices in India. We have Bengaluru and Chennai. We are expanding our sales office in India to have 2 more within 2026, and that will be in Delhi. Oh, sorry, Pune is our other sales offices. Our expansion will be into Chennai. So we will have a total of 4 sales offices throughout India by the end of this year. It is a huge opportunity for us to grow our business in India. And as you know, India just globally is a focus of the technology industry. So as India grows, Mauser wants to be a part of that growth. So we are investing more and more resources to help customers throughout all of India. This is last year's sales. So last year we ended up at about 3.3 billion in global sales. And you can see, hopefully you can see that we have the different regions and how they did. We grew in every region last year, with Europe probably being our fastest growth when it came to the end of last year. Asia a little bit more slow and steady. But this year, boy, the industry just started to take off. And you know, there are certain things like AI, automation that are really helping the industry grow. What we anticipate this year is going from 3.3 billion in total global sales last year to over $4 billion in sales this year. We anticipate the growth to continue through 2026 into 2027. And I will tell you, it's a big question mark on what happens second half of 2027 in our industry. But right now, all the signs within the electronics industry is pointing up, and it's very encouraging for us. And what's even more exciting is all these evolving technologies, these disruptors like AI, that's playing a much more important part in our business. So when you look at technologies, when you look at needing products in your hand the very next day, please look to Mauser Electronics as your provider. My very first slide says we are the new product introduction leader, and here's the data to prove that. If you look at the new products that were introduced by Mauser going back to 2018, The red is probably our closest competitor. They're red because hopefully you know who they are. They also are a e-commerce distributor. But you can see that we far outpaced introducing more new products by the year than our closest competitor in the industry. What happened in 2022, 2023, and part of 2024 is that's when we went through the pandemic stage. And what happened in the pandemic stage is a lot of manufacturers were focusing on trying to keep up with capacity and not much focus on new product introduction. We see those manufacturers coming back, putting more focus on new product introduction, and that trend started to increase at the end of 2024 into 2025, which really helps us get their latest technologies out to you. So some of the key takeaways, Mouser is a top 7 global authorized distributor. We have locations all around the world. We aren't just a website. We do have 28, adding 2 more in India this year, locations around the world to have local people dealing with local customers. We reach millions of engineers and buyers globally. And also, our customer count is well over 650,000. So when you're looking for authorized distribution, which to me is very important, look to Mouser Electronics. And when you're looking for the widest selection of components that are on our shelf in that warehouse that I showed you, please look to Mouser Electronics. So that's everything I have. If we can get to the star of the show. And thank you for your time. And again, thank you for spending part of your day with us.
Thank you so much, Kevin, for the wonderful insights and setting the tone for today. Up next, we have Mr. Jailendra Kumar, CEO of High Norm Systems and Services. Little bit introduction about Mr. Kumar. Jailendra Kumar is a technology and business leader with 30 plus years experience across ISRO, DRDO, Philips, Samsung, and BAE Systems. He has built and scaled engineering organizations and commercialized technology platforms, and now advises boards, founders, and investors on technology strategy, innovation, and scale up. Please welcome Mr. Kumar to the stage. Thank you.
Thank you, Pooja. I'm sorry. Thank you, Payal. Good morning. Such a good crowd, and it only says that you're so very interested in getting to know where to go from here in your technology pursuit. And Mouser being the key supplier to your to take your dreams to fly, I think you're in the right place. I will share some of the thoughts I have gathered through my experience working for myself, working for the industry, and I hope hope it resonates with you. So, in the electronics, we all started with. You remember, not many old people here, but humble 885, 886, 386, so on, so on, so on. And today we are thriving on ideas. I want to build something, and then I look around for what can I get ready-made, and on the top of that, I want to build. So that is why I thought I'll talk about building next generation of intelligent electronic systems, right? And to make that intelligent electronic system, we should be kind of aware of what is the industry going through, which transformation going through, where is the technology converging, what are the design imperatives, um, and what is the opportunity India offers you as an electronics engineer, systems engineer. So as you can see, we have moved from component to board to systems to platforms. And I'm carefully saying here ecosystem. Why should I bother about ecosystem development when I'm worried about building my own product? You will see through that. Why we should not end up at building a platform, but also build the ecosystem for ourselves. Because the value creation that you're looking for, that comes from the software and the system level integration that you do. Don't get hung up on the figure. 60% could be a specific, somewhere it is 90%, somewhere it could be less than 60% as well. Depends on what is the application you're talking about. But you all agree that the value is coming from configurability, the software programming. And beauty of that is that you can modify after launching the product into the market. Very quickly you can adapt next version and so on and so on. So I think all of us are looking for differentiation to succeed in our respective businesses, right? And my assertion is that the differentiation comes from integration of multiple hardware pieces and software pieces or subsystems, as you say. That is where your differentiation comes, because there is no straightforward one kind of product they can build. Today, as you will see through the examples, any product that you make requires hardware, software, knowledge through the other disciplines of engineering and so on. So that differentiation is what we are looking for in our design creation. So what are the imperatives of design? The individual engineers in your workplace, you as a manager, you will assign a piece of task to that engineer. The engineer carries out that task in best possible way, less time, good quality, error-free, etc., etc. But there has to be somebody, including yourself, the individual engineer, who has to be worried about all of this. Am I designing for higher performance? Am I designing with lowest possible cost? Is my product is security built into it, or security is somebody else's business? Is the product reliable? Now these are all thoughts which have multiple interpretations. So for example, somebody will say agile workflow, where I need to just get some working product into the market. Why should I worry about, why should I invest in reliability or quality? But I don't think that you succeed in the long run using that philosophy. These are the habits. This should be part of the engineering habit, that I build reliability, I care about sustainability. What can be, when I'm designing something, am I sucking all the natural resources for my own work, or can I also minimize that? And AI has become integral part of today's design. No matter what is the product, you will find some space for AI in that. So I call it imperative. You can think of as a good design habit. So it all starts from the semiconductor at the core, and then you build embedded systems. But then today's system, can you imagine a system which works without connectivity, without connectivity to cloud, without having edge intelligence, without having AI, some bit of AI? So if your pursuit is to make intelligent system, you are actually should be aware of all of these aspects of the product, right? Now, look, think through this. What was the genesis of taking the compute or the intelligence at the edge? So, somebody who is from kind of little old school will think that we used to think of bigger systems which are very intelligent, very powerful, and you log into that as a client and so on, so on. But then you don't make autonomous, right? I mean, you are still hooked to that. If there was a failure, then failure is for the entire organization, entire platform. These days, we want the intelligence process at the edge itself, at the endpoint itself, right? So edge intelligence is kind of given as an essential attribute of intelligence system. Again, graph is to show the trend. I really don't want to haggle on the numbers. Number change every day. Every day numbers will be changing. Somebody estimates, somebody else estimates better, and so on, so on. And when you have cloud connectivity, what is the cost? What is the penalty that we pay? The latency, connecting to the cloud, retrieving the data, bringing it back, processing, and again sending it back to the cloud so that users can use that. That has to be low as possible, right? Then, are we really worried about energy? I mean, it's like I open the tap, I get water. I switch on the wall socket, I get power. That's not the case. Each of us have to take responsibility for our, energy consumption or any resource consumption for that matter. So we need architectures which are high performance but lowest possible energy as well, right? And data privacy is a new thing. It doesn't concern your hardware design, so to say. Of course, to the extent of encryption and etc. built into the hardware, but some layer of the product that has to be guaranteed as well. Now, these things that we talked about, let us take an example from, let's say, a drone, which is very, very commonplace today. Look at the parts. It has rotors, some mechanical body, and what else? I mean, each component was well known. All of us knew about those components. But when you put them together, you make a beautiful intelligent system. What is the drone? What is the best, like, first thing that defines drone for you? It takes your senses, your eyes. Let's say it has a camera. My camera has gone wherever I wanted the camera to go. I'm no longer constrained by the field of view of the camera from here. Okay, I'm taking the camera itself there. If it is carrying a radar, a small radar, then I'm taking radar somewhere else. So drone is that beautiful platform which takes your senses into far away from you, into where you want it to take. That is possible by, that's what I'm making the point, that is possible by intelligent system integration. And a drone engineer cannot say, I'm only an electronics engineer, I'm only a mechanical engineer, I'm only a aerodynamics engineer, and so on, so on. You're all of it as a team. And each one has to be considerate about the other disciplines aspects, right? So mechanical engineer is concerned about, will the electronics fit into my design? The electronics that will have to consider, will it work when it is going 50,000 feet up in the sky? It has to worry about, will my sensors work when it is going through, it is covered by vegetation in the forest? All of that, right? So sensors, communication. If I have a device or a flying machine which I have flown away, but it goes to a point where I can't communicate, what good it is for me. So whatever is my flight envelope, I should be capable of communicating with reliably with this device at all times, right? And only I should be able to communicate, not my neighbor, not my adversary. So the communication security also has to be built into that. Then you are doing all this for a purpose. So you need processing, To make it autonomous, you add some layer of AI, and obviously it will navigate. Or sometimes you make it auto-navigate. They don't navigate itself. I just have to feed the coordinates. Similarly, if you take a smart factory, again, it's a combination of sensors, controllers, AGI, cloud analytics, and real-time data display as well for the factory manager, for the floor manager to have a view of what is happening on the floor and where it needs attention. Think of a car, which was a purely mechanical piece loaded on 4 wheels with ability to move freely on uneven roads as well. But no longer, car is no longer that. A car you have got, do you imagine it has more than 100 processing units in a car these days? If you go to service your car, what they do is they connect the test port into their computer and get to do the health check of the car, and then only the mechanic gets to know what is the problem with the car, if at all any. So electronics has pervaded so well into all aspects of life, all aspects of engineering discipline, that it becomes a horizontal resource. And again, like in drone, like in other examples we took, all of that, the common element of that is sensor connectivity AI. Of course, here you're dealing with power electronic systems, somewhere else you're dealing with aerodynamic systems, somewhere else you're dealing with harsh environment in a factory or so on. So convergence is what I'm emphasizing here. When you go to mission critical systems, apart from things that we discussed, we talk about reliability, right? That means it should work no matter what. How it will work, all the elements you have to build. So you build redundancy, you build resilience, and you build the systems which should last for years together. Now, counter example also. You say, okay, should I build a phone for with 10 years or 20 years life? Possibly not. But then that's not a mission critical system. That's a daily use commercial electronic product. I'm talking about a specific example here where it's a mission critical system where example is a rocket, a spaceship, or etc. etc. So these features have to build as into the system. No matter it is mission critical, everyday commercial, or whatever, have we designed for failure? Okay, is my system fault tolerant, or it at the first glitch it shuts down? Keep that paradigm while you're designing your system. How much redundancy I should build in the architecture? Of course, it costs money, right? Redundancy costs money, and we have to be judicious about how much redundancy I can build in what class of product. Can I predict maintenance? If any system will require maintenance, can I predict maintenance? That too, I'm not talking about huge plant. I'm talking about any system that you build. I'll give an example again from aerospace. What happens? Has anybody considered if a plane is flying and it is like 20-year-old? Do you know when it can fail? When it can crack? The wing can develop crack, for example. Can we take that gamble that there is even 1% chance that the wing skin can crack? Right? So that's where we need predictive maintenance, isn't it? That's an example to set the matter here. So what we do is, there is a concept called IVHM, Integrated Vehicle Health Monitoring System. We put sensors on the wings itself, stress sensors, and it continuously keeps measuring the stress on the wing, on the surface. If there is any upcoming problem also, you get to know before. So you know the upcoming problem before you take the plane to air. Right? So And the new, new arena, new thought that you should build into is the cyber security. How resilient your system is to cyber hacks, right? Security is always a race, right? You create a safeguard, and the group which is trying to oversmart your safeguard will create a new algorithm, new solution. Then you create another safeguard better than that, and then the other side creates a new one. It's a race, but don't opt of the race. Don't opt out of the race, isn't it? We have to be in race. We have to be, at least the known state of security is what we have to build. Then some system design could require power efficiency, right? Of course, there is always an interaction between power and performance, as this graph can tell you. Sometimes performance can come at the cost of power. Sometimes, if you give preference to the power conservation, performance can be degraded. But again, I'm saying discretion is ours. What I'm designing and where can I place my system on this cross curve? What I can accept, what is the acceptable performance at what power level? And when I say power, it also goes about stuff like thermal and so on, electromagnetic interference, etc. So, good news is that India has a great opportunity for electronics market these days, right? You've heard about India semiconductor mission. You've heard about a lot of semiconductor plants being set up in India. So, and semiconductor is only the start of the cycle, electronic product cycle. So once those things come, then you create boards, then you create the development system around it, then you create the real use applications, etc., etc. So there is a full cycle electronics revolution happening in India, and you are very much part of it. Like it or not, you will be part of it. So take advantage of that. But the difference, what will make a difference is this. Think of this. When Tata didn't know how to build a car of their own, what were they doing? I mean, cars were being built in India in 50s, 60s, and so on, last century. We were having what is called contract manufacturing. So you take the last blueprint of design and you build it. When you do not know how to build an aircraft, you do the same thing. How long can you survive that doing that? There will be a time when somebody else will be doing the same job cheaper or possibly better, and you get out of the market. So the new slogan is design-led manufacturing. I don't only manufacture, I design here, design and then manufacture, right? And that opportunity has come. We have, and to help us do that, we have global supply chain available. Kevin just now said how Mouser is integrated in the Indian market. Supply chain is available. So go extra mile of designing and then manufacturing. Of course, this I don't think we need to emphasize here. A lot of you are here, innovators, or at least aspiring to be, starting up something of your own. Now, how does this startup operate differently from a larger corporation? One, we have to be very clear when we take that path. So if you are an innovator, if you are a startup, you are actually having a mission to push the envelope. You want to do deep tech innovation. It costs money, and you must find money. Also, your costs are low. You're willing to take pains. You're not looking at a crore rupees plus car to move around, possibly. You are willing to forego your comfort to achieve this innovation. That was your passion when you started the company. So the burden of innovation is again naturally falling on the innovators or the startup angels. So because of because of not very complex layers of administration, we also have advantage of rapid experimentation. And since you have no processes, no, I'm sorry, legacy processes to go with, you can innovate your own business models also. Not only technology innovation, but you can also innovate your business models, right? So building further on that, this is my message to the future engineers, the crowd here. Let us do system thinking. Think what you are at the end product that you're building, not only what is the task assigned to me in that bigger system. Although you will focus majority of your time and attention on your own task, what is the end product? Everybody in the team has to be aware of that and be aligned on that. Everybody today needs AI literacy. Level could be different. Either I am creating a new LLM, or I am just a prompt engineer who knows how to use AI. But we need to be AI aware, AI literate. One cannot say my job is to design hardware. So what software? What I have to do with the software? No. Specialize on the hardware, but be aware what software requires from the hardware engineers. See, the other way as well. If the engineer is software engineer, but cannot shade the innovation that why should I worry about hardware? Until I know what is the capability, what is the limitation of the hardware, how will I create my software? And product mindset, I have emphasized that. A bit of business understanding helps because whatever you're building for a market. I mean, you want to take it to the market, you're wanting it to be useful to the people. So what segment of that people is what I am building for? Okay. So if you thought of all of this, then this is our journey. We conceive of an idea, assemble the products, create a system, intelligent system, from system to products, and then it has to be aligned to the business. You remember first slide I was saying ecosystem. Now ecosystem plays here. Ecosystem plays here because today no company, no group of people works in isolation, right? And you don't want to do everything of your own. I mean, think of Maruti as a car maker. Do they really do everything that they do? Tata's, for example, do they do everything that they need in their product? There are suppliers, there are designers, so everybody needs everybody. And it is not always the competition. Competition has a hidden collaboration as well into it. So, and that was my message of ecosystem there. So if I am strong in something and you are strong in something else, it's better for me, two of us to collaborate than compete. And it will be a waste of resources if all of us are running the same race. Why can't I be expert in everything? That's not possible. And that's, the time, there will be a timeout. So the message is build systems, not just the products, and that will give the competitive advantage to you, your team, your company. And that is I think that is all the time I had for. So in summary, look at the value, design, create the value. The intelligence will, the differentiation will come from your integration, how skillfully integrate these components. Always think of edge computing, edge AI. Be aware of what is the domain of the product. Is it mission critical, commercial, off the shelf, etc. And benefit from the India's design opportunity. Okay, that is all I had for you. I think in the time that was given to me. Do we have time, Payal, for any questions? No, later? Okay, sorry, this the schedule is tight, but I will be around for some time. If you have anything, I will be very happy to interact with you. Thank you.
Thank you so much, Mr. Kumar. Up next, we have Mr. Navneet Vinayak from Little Fuse, who will walk us through their topic, selecting the right protection for high voltage DC. Please welcome Mr. Navneet to the stage.
Good morning, everyone. So, I hope everyone is settled. Yes, good. So, I'm Navneet Vinayak. I'm from Little Fuse. I take care of the industrial business. So, it's basically, we call it energy and industrial infrastructure. So, it's a great time in India today, world actually, and we are talking about AI. So, we'll talk about AI today. AI is everywhere. We are doing a lot of stuff with AI. I'm personally doing, like, I'm putting a medical report on AI, Chat GPT, before even I go in the evening to a doctor, and within 30 seconds I uploaded an X-ray, and within 30 seconds, even less than that, ChatGPT gave me a complete analysis of what it was. Yeah, we should not trust it, but that's the capability of AI. My daughter, she gets a sample paper from her school. She's uploading on ChatGPT, asking it to prepare 3 more similar sample papers, and then she's sitting and solving them. That's the day-to-day AI we are doing. Corporates are running codes on AI. How this AI is working? So we do something on ChatGPT, Copilot, or one of the AI tools. It goes back to a data center. Data centers are huge installations where the servers are running, servers from big companies are running, which are doing the AI work. I believe they have their own method of collecting data from multiple sources, collaborating it, and then summarizing the data and presenting to us. As a user, I get something what I need. These data centers are like big buildings. There's like a 1,000-meter building on which we have the server sitting there and a lot of other equipments. Now, these servers today, I've seen like data centers can consume hundreds of megawatts of power. Even they are moving to gigawatt range of powers. When something is consuming 100 megawatt, which is equivalent to maybe a small town or multiple villages, that much energy is being consumed by one data center sitting in a 1,000-meter or a 5,000-meter area. It is getting upgraded to gigawatt level because more AI demand is coming. We have all limitations on AI. If I do 2 photos search on ChatGPT, it tells me my quota is over, I need to come back tomorrow. Because today the processing power is limited and they need to monetize it. So everyone is getting small quota unless we pay and then we get higher number of tokens or higher quota. As data center infrastructure will evolve, more and more data centers will come up. This use will expand. But with that, power consumption will expand. So if we see a data center, we have servers, racks sitting on one side, but then the whole, maybe about 80% of the area is actually consumed by things which help these servers run 24/7, 365. We need AI. Even in the latest war, I think a lot of things were dependent on AI. They tried to attack some data centers because AI has tremendous capabilities, and to run this 100 megawatt server or 10 megawatt server, a lot of power management is needed. We need to have a source of power. We need to have a lot of protections, lot of intermediate stages to ultimately power that AI chipset. So Littlefuse as a company, we are about 100 years old. We have been doing power control for grid infrastructure, for telecom, a lot of these different subsections which are combining and getting fit into one data center, which is the buzzword today. So we have a lot of experience on this market. We have been trying to upgrade some products, bring in new technologies or new products which will help protect those servers, help run them efficiently. We do power control also. So those are some things which I will talk about today in the next maybe 30 minutes or so. So these are topics. We'll talk about a little bit about data center overview, again from a power point of view, not on the server side. Architecture, how is it evolving? This is a very fast evolving industry. It's continuously, the specs are changing, as you will see. Some things on, then I'll talk about some subsections like medium voltage, what solid state transformers are coming up, on-site power backup. So some sections I will talk about what we have to offer and how we are distinguishing and helping customers design newer solutions for this market. So how the power flows, we have grid, which is there can be a source of energy which is grid or solar or wind. This comes in medium voltage, then it has to be brought down to 415 volt typically today. So there is power conversion, then it is brought down to 48 volt, 58 volt or 400 volt, different voltages. Lot of protection comes in between. Then we have UPSs which give the uninterrupted power supply. If there's a grid outage, we cannot have the server resetting. So there are a lot of UPSs used, and typically these UPS can only support for few milliseconds or few minutes of power backup. Then we have energy storage systems. So in case the grid outage is longer, lot of localized BSS systems are also getting installed. Ultimately, they convert it to a level which can be used by the racks. On almost all of our slides, you will see images of different products which we support in different subsections of this. Like in this slide, I'm just showing some components about what we have in protection or power conversion, something sensing. So this is a common thing. We'll share the presentation with you, so I'm not going through all of these things. I want to talk about overall the bigger picture today. Okay, so how the power is evolving. Until few years back, the power supply is typically 3 to 5 kilowatt bricks were getting installed in racks. They were powering the telecom systems or smaller data centers. Now that same power shelf is still on 58 volt, but it has gone up to 100 kilowatt also. So the power density has increased with silicon carbide, gallium nitride, new technologies. We are getting higher power in the same shelf. But when AI server is going to demand 1 megawatt of power, running it on 58 volt, or imagine I have a system and I'm having 58 volt going from one rack to other rack or one place to other place at 1 megawatt is 20,000 amperes. That's a huge amount of current. We don't want to handle that much. So we are that voltage is being increased to 800 volt DC now. And almost every major player is working to build power supplies, to build the whole ecosystem, upgrade it from the traditional 48, 58 volt to 800 volt DC or plus minus 400 volt DC. So that jump is happening today. Little bit more today's architecture. So we have medium voltage voltage coming in up to 35 kV. We have a step down transformer, UPSs, and then we have AC power distribution units. So these are basically distributing 480 volt across the backplane. And then wherever I have a rack, I'm going to plug in my power supply. It's going to bring that down to 58 volt. And then that 58 volt is further 12 and down. This, starting from next year, already a lot of work has happened. This is going to move from traditional 58 volt or 50 volt to 800 volt DC. So the front end still remains the same. We have medium voltage grid and other things, but then there's this concept coming in, which is an HVDC sidecar. This sidecar is basically going to generate 800 volt at 1 megawatt, and then that 800 volt goes to different sections, and then there's a converter from 800 down to 12, and then from 12 to even 3.3, 1.8 to power the servers, fans, and other things sitting in that individual rack. This is happening today. We are working with a lot of customers on this HVDC sidecar, which has a lot of things. So moment we go from for 58 volt, which has been around for decades, almost every telecom industry, even a lot of products which were used in automotive low voltage have matured at that 58 volt. Now with this 58 to 800 jump coming in, a lot of innovations are needed, because 800 volt is more risky. We need to redesign the protection schemes. 800 volt is easy to manage in terms of power conversion because the current comes down, so efficiencies improve. So those, sorry, what happened to this one? So yeah, and then after this, in the next maybe another 2 to 3 years, we are seeing that this medium voltage transformer, the traditional transformer, is going to get replaced with solid state transformers. So solid state transformer, I'm also learning that topic. I started learning about 4 months back. So it's basically you have a lot of power supplies connected in series to handle 35 kV. So the devices individually are not 35 kV rated, but they are connected in series. So they sit across a 35 kV bus, and the output is parallel. This thing will replace all the intermediate stages, and will straight away have a solid state transformer which is going to take 35 up to 35 kV in and can give 3 to 6 megawatt output. This is where R&D is happening today. Next 3 years, we'll see actual large scale deployments with solid state transformers. And data center is a very good use case because we need 800 volt. We don't need AC output. Even if AC is needed, they might have a small inverter sitting somewhere to give 480 volt for some of the conventional AC loads, but majority of the loads are also shifting to DC. So this is an exciting phase for electronics engineer, because the moment we come to power supplies, SMPS, which are going to like 100 SMPS in one SST or 300 SMPS in one SST, it's all silicon carbide. I heard even gallium nitride is coming in. These things excite power electronics engineer. We are going to need a lot of more complex electronics, and we as Littelfuse, we have, I'll show portfolio at the end. We have products on power control. We are also on protection. So the moment we go from a linear metal transformer to semiconductors, more protection will be needed. So that's where we as a company are gearing up with launching more solutions to cater to this evolving trend. Okay, so now I'll talk about subsystems, how the power is flowing from medium voltage down to the HVDC sidecar. I'll take some time and talk about these things in between. So medium voltage protection, typically we have, so it's, what we play is on the, lot of relays are needed, monitoring relays. So an arc flash on the medium voltage side can cause the whole site to burn, to explode in maybe 100, 200 milliseconds. So specific arc flash relays are used. If there's an arcing, a shorting happening, that has to be identified and controlled shutdown in a very, very quick time. So we have specific protection relays for that. Then neutral grounding is very important, because if on the substation level the neutral is connected to the ground, and that monitoring of the connection is very important, because if the neutral floats, the whole line can have damage where the cost will be huge to repair it. And then a lot of different fuses are used. So we have a very good range of relays which we support, both for the arc flash and neutral grounding monitoring relays. We can go up to 25 kV on the NGR relays, and then arc flash relays, basically we have them on fiber optic based sensors, so they sense a flash happening and then trip the circuit breaker in a very, very short time, so that big catastrophic damages don't happen. And these are products which are legacy products. As I told starting of my presentation, a lot of our expertise into conventional grid is getting into data centers, and that's where we are seeing customers needing them on the data center side as well. Along with this, Little Fuse, our name as Fuse, we are going to be a 100-year company next year. So fuses is something we have been making for 100 years. Fuses for this application, we have medium voltage fuses which can go up to 15.5 kV, up to 500 amps, different ratings as per NEMA and NC standards. So this is, again, the demand for this will increase as we move from conventional transformers to solid state transformers. More and more medium voltage protection will be needed. So we have products on that. And then also on the secondary side, a whole range of UL fuses. So there are fuses which are designed for short circuits. There are fuses which are designed for overload and short circuit. So we have a whole range of different class of fuses with different ratings. I'll talk a little bit more about fuses when I come to another slide, which will be interesting for the audience. Solid state transformer still evolving, but basically what is it? It's a DC-DC converter, maybe which can take 1200 volt input and convert 800 volt DC output. And then a lot of those converters are stacked in series to reach bus voltage of 35 kV. So as we do power supplies, we have silicon carbide MOSFETs, modules, thyristor diodes, solid state switches, and lots of fuses are again needed. I'll talk about the solid state switch here. So when we have a module sitting across the line, in case there's a fault, we need to isolate it quickly. So we have this, we have a very unique IGBT, which is a press pack IGBT. Typically IGBTs are in modules. This is a double side cooling IGBT. So you can easily connect them in series to reach 35 kV or even hundreds of kV. We supply these to HVDC transmission systems as well. So these are getting used now for the disconnect switch, which will be sitting across medium voltage line. So as you can see, multiple switches can be connected in series to reach the 35-40 kV level, and they will give the fast disconnect in case a fault happens. So the idea behind all the protection is to localize the fault, limit it at the level where it is happening, and not allowing it to disrupt the whole system. We don't want the whole data center or anything to come down. One rack goes down, it's okay, the other should keep on working. So this is where we are finding use for this disconnects. And next area is, so we have power coming from grid or solar, but there can be interruptions in grid. So we need on-site power also. Huge generators are getting installed, and again that generator market is booming with the data center demand. So you can see a lot of huge demand for big generators is happening today. So for generators specifically for this power generation section on-site or big plants, Little Fuse acquired a company, I think about 5 months back. It's called Basler Electric. So Basler Electric has a huge legacy into products related to power generation, like excitation systems. So when we have a generator running, it needs an excitation. So we develop those excitation controllers which can give up to 10,000 amps of excitation, voltage regulators to regulate the voltage, genset controllers, and then again a lot of protective relays. So this is after medium voltage, we need on-site power. So for on-site power, we have these products from our latest acquisition, Basler Electric. Moving down, after generation. So if you see in the block, after this generation, utility and generator, now we need a transfer switch. So that transfer switch needs to identify if utility is there, give power from there. If generator is there, give power from generator or UPS. Again, time is critical. So rather than conventional mechanical switches, static transfer switches are being used, which are again based on thyristors. These big thyristors are used. I have them on demo at our table as well, and we do make modules as well. So if you see transfer switches, we talked about these on the medium voltage side, and then on the low voltage side we have conventional static transfer switches using two thyristors back to back, and these are used to select which power has to be given to the load. We have capabilities to make even stack modules. We supply these ready-made stacks as well to a lot of customers for this application. Okay, next, energy storage. So now we have generated power on site or we're getting it from the grid. There's a UPS, but we also need local energy storage in case everything fails. BSS is also getting deployed with data center. So BSS has already moved to 1500 volt DC. Now we are working with some customers on 2000 volt DC, because again, same thing, solar started with 1000 volt or even lower. It went to 1000 volt maybe about a decade back. I think about 7-8 years back, it moved from 1000 to 1500 volt. Higher the voltage, lower the current, better the system design. Now it is moving to 2000 volt. So we have a lot of special fuses which we support for this energy storage. This is an application where again, I have, how does a BSS look inside? So you have battery modules. A lot of them are connected in series or parallel to get that particular voltage and current rating. If there's a fault at one of the battery pack, we need that pack to be isolated. We don't want the whole system to shut down. So we have different levels of, fuses which we have designed for this application. Like we have ESR, which are faster acting, but they are for the module level. We have PSX, which are slightly slower, so that when a fault happens, the one which is designed to fail should fail, not the master fuse. So again, this is where we help a lot of customers simulate how a system is going to respond in fault events. That's one of our very strong capability which we do with our customers. So if you're designing something on BSS, you need help with the fuse selection, you need help with the DC contactors, those kind of products, please let us know. We'll be happy to spend time with you, help you select the right part. Okay, next one. Now, all of this is coming to the sidecar, which is the new thing which is coming up. So HVDC sidecar going to take AC input, generate 800 volt DC output. Again, lot of power electronics here. So all these you see are basically power supplies. These will be AC/DC rectifier stacks, and then there will be some PDUs and other things in it. All of these things, we are again having a lot of components which are going into this sidecar application. So we have new MOSFETs released, on top side cooling, high density MOSFETs, which can be used for both power control, and then also if you see a traditional power distribution, PDU we call it, power distribution unit, basic language or extension board which we use at home, similar PDUs are used in data centers to power all the subsystems. Traditionally, a PDU which was working on AC had one circuit breaker, had maybe one switch and couple of more components, because everything was AC. Now, when I need to distribute 800 volt DC inside that data center, I need to change the architecture, because DC will have to put in a different kind of circuit breakers, and so the demand from a conventional AC circuit breaker to a DC is going up, because you want fast turn off at 800 volt. So lot of people are now designing circuit breakers using solid state devices. So we have MOSFETs, common source configuration, acting as a DC switch. both the MOSFETs connected in a common source, and a lot of them connected in parallel to bring the RDS on now. So these switches act as a very fast turn-off mechanism in case of a fault, because an arcing at 800 volt DC, if I don't have the data, I'm trying to collect that. But typically, if a fault happens at 58 volt, the time for the system to go into a very big catastrophic failure will be higher than a fault at 800 volt, because 800 volt will have a lot of more energy, and it's flat DC, it's not an AC. So we need faster turn off in case of faults happen. So the PDU design inside data centers with the DC bus is moving from a normal AC circuit breaker to static switches. So static switches means MOSFETs, a lot of these silicon carbide is used. I put an example here, but we have now RDS on going to sub 10 milliohm level as well. And then this is good. MOSFETs very fast turnout, but we also need galvanic isolation. So along with the MOSFETs, we are also having customers, so they design for fast turnoff a MOSFET based solution, plus a DC contactor is used for providing the galvanic isolation once the fault happens. So we have again worked out a complete range of DC contactors for data centers. Right now it's at 1000 volt, but we are seeing this 800 might go to 1500 also in the coming few years. I believe why 800 was selected, because EV had already matured to 800 volt. So it was easy to adopt to that level where some ecosystem was building on the EV domain. But we believe 1500 will be the ideal voltage for data centers, maybe 7-8 years down the line. So a lot of these things will again see a transition. We have contactors up to 1800 volts, so we have products which we are supporting in this domain. Now comes the interesting part of fuses and why a lot of different fuses are going to are used. So I am going to show you 3 slides of fuses. I'll start with the highest current one. So this one is 1400 amp rated and goes up to 1000 volt DC or 1300 volt DC. These are big fuses. They are used on the system level. So when a fuse blows, when a short circuit happens and the fuse is expected to open up. So fuse is basically an element. Silver, copper, alloys, these elements, once the current exceeds a certain level, it starts to melt. Once that melting happens, the arc will be formed. Current will try to continue. So during that time, a huge amount of energy is generated. How much short circuit is there in the system? It defines which type of fuse will be used. Now, this fuse, which is on the main system level where highest current is flowing, if you see here, it has a breaking capacity of 150 kiloampere DC. That means when the short circuit happens, even if 150 kiloampere is going to flow momentarily, the fuse will melt, open up safely. There will be no fire, no body breakage, no bursting, nothing. This is, as a fuse manufacturer, for me, it is the right way a fuse is going to open. Open silently and disconnect the system. Now, when we go from a main system level down to maybe module levels or rack levels, this is where we have the next range of fuses coming in. So these are also 1000 volt DC fuses, but if you see here, the breaking capacity keeps on going down based on where I'm going to use. So I have 100 kiloamps which are still going to be used on maybe rack levels. Then I have 50 kiloamperes which are going to be used on module levels. If I go further down, I also have products which can go 20 kiloampere or 10 kiloampere. These are different types of fuses. Plus, one more thing, if you read it carefully, so we have 2 types of fuses. One is partial range, which is short circuit. So these are designed, these are used where we want the fuse to open only during a short circuit event. So if a short circuit event happens, a huge current flows, we don't care about 2 times the overload or 4 times the overload or 8 times the overload. It's like 100 times the rated current. The fuse will immediately blow. We also have full range fuses where we need the fuse to also open at, say, 5 times the rated current. So at overloads also. That's the difference between partial range and full range fuses. So as we go down in module levels, the faults may not be 100 times the rated current. they might be 10 times or 20 times. So instead of using a short circuit fuse, you need to use a full range fuse, which can also act at overloads. That's the difference. After this, I have one more slide on fuses. Now on the PCB level, so we have DC-DC converters. Here we have a different range of fuses. Here if you see, the interpreting comes down to 10K or 20K, because as we keep coming down, the short circuit current, because of the system impedances and other things, will keep reducing at that particular level. So this is where we have a lot of PCB level fuses. Again, when we move to 1000-volt DC, as I told you, when the plasma arc starts to happen, we need to contain the energy. So conventional AC fuses cannot be used, because AC is a sine wave. It's going to go to 0 in 10 or 8.3 milliseconds. This is not the case with DC. So this is where you'll see a lot of different types of fuses, but it's very, very critical to select the right one to ensure when a fault happens, the thing which needs to be isolated, only that thing gets isolated, not the whole system. And if you're designing something, we can help you design the right fuse, right combination of fuses for your systems. Last few products, so we also released several TVS diodes. So as I mentioned, circuit breakers are moving from electromechanical to solid state. I'm putting 1200 volt silicon carbide MOSFETs, but that MOSFET needs protection, because a surge can come which can be 2 kV or 4 kV. So we have a lot of TVS diodes which are used to protect those MOSFETs. A huge range. I've just put one product, but we have, this is 3 kiloampere, but I have up to 10, 15 kiloampere products also, which are getting adopted in different PDUs or a lot of electronic designs. We also have on the output side, now ultimately we are going to generate 48 volt, 70 volt. So we have miniature fuses, because power density is increasing. You don't want to use a fuse which is like 10 by 50 or 8 by 40 size across everywhere. So we have smaller miniature fuses which are coming for the low voltage DC system to increase the system density. So again, same things, same fuses, but integrating them. So like this white one which we have just released, this has an interrupt rating of 14 kiloamperes. That's a huge amount of current. So you can straight away put it on the output bus, which is maybe sitting close to a battery or some kind of applications. Right, and we have a huge range of silicon MOSFETs as well. So we have planar technology, we have super junction, we call it ultra junction, and then different voltages. Just put one or two of them here, but again, we have a huge range of MOSFETs. If you are designing something unique or conventional, we should have solutions for both of them. Okay, that's about the products which I wanted to talk. Maybe I'll take another 5 minutes. I think I have 5 minutes left. So 5 minutes for about Little Fuse. You can find all this information on our website, different web pages. We'll share the presentation so you can get the QR codes, different end markets, what resources we have. And again, a lot of these guides are available on our website. We also have a very good understanding of our products and labs where we manufacture those products. So if you're using a fuse, you want to understand how the fuse or a varistor or a TVS diode or any component which we supply, how it is going to behave at your operating conditions. We can try to simulate it in our labs. We have these testing services available. Then these are standard options available. But testing is something which we take pride on, because we help a lot of customers understand how the product is going to perform in their operating condition. Okay, resource library is there, and then this is again the same thing. So a lot of other catalogs are available on our website. Please do visit it, and you can get the information. Globally, we are present across all major locations. In India, we have our office in Noida, and we have a manufacturing in Kanpur, where we make right now some specific products for aerospace. And a lot of our manufacturing is otherwise concentrated in Eastern Asia. We have plants in Philippines, Vietnam, Japan, and several of them in China. Also fabs in Europe, Germany, and UK. And then I think about 13 plants in Mexico making different kind of products. So we take pride into manufacturing majority of the products we sell. So we are not just a company which is gonna see something, put a label and sell it. We manufacture a huge amount of products we make. We do use contract manufacturing somewhere, but our strength is into manufacturing, which helps us uh, minimize lead times, also keep on innovating, because we know how we are making the products, what can be improved, what, like as I said, if the data center starts moving from 800 to 1500 volt, we know what we have to do in our products to adapt to that market. Right, so that's the last one. We help our customers in different domains. We have a very broad portfolio of products. Application expertise, we have FAs based in Bangalore, Pune, Delhi. In India, you're designing something, you can reach out to us. Our FAs will help you design the products. Customer service, so we have several distributors, and almost everything which we make is first stocked on Mouser before we release to the market. So if I am releasing a product, you'll get it on Mouser before I release to the market. So that's our way of supporting, and Mouser helps a lot in that. And yeah, compliance and regulatory, I think that's one thing which I didn't mention till now, is because fuses and everything deals with protection. So we know if you're designing something for UL, we can help you. We don't have UL, we don't do certification of UL, but pre-compliance, if you're doing UL 1449, what needs to be done, we can help you out on that. So that's the last, I think, thing which I had to mention. So that's it. Thank you. Thanks for your time. I think I am on time. Yeah, thank you. Thank you very much. Thank you very much.
Thank you so much, Mr. Navneet. All right, everyone, time for a quick breather. Refreshments and snacks are right outside, and please go grab a coffee and stretch your legs. Please do swing by our partner booths while you're at it. We'll be back shortly. Thank you.
Something big. You dream. You plan. You take measure of yourself and the challenge in front of you. You put in the work, and you put on your game face. That's the road to success. Leave nothing to chance. At Mouser, we know a thing or two about going big. Partnering with over 1,200 leading electronic component brands and helping them expand into markets around the globe has made us the fastest growing distributor in the industry. Maintaining the world's widest selection of inventory, embracing sophisticated warehouse automation, having local customer sales representatives capable of answering your questions about a product, its availability, or the status of an order. Well, that's just what we do at Mouser. We've made the commitment to remain the leader in new product introductions and to develop the productivity tools that make buying from us the thing over 650,000 customers have made a habit. Because at Mouser, we leave nothing to chance.
The Price and Availability Assistant allows you to check stock prices, see what's available in inventory, and bulk add products to your cart. You can tap into the power of your assistant in 3 ways. Drag and drop your spreadsheet right into the system, copy and paste your data, or manually enter your data. Here's what you need to know before you move forward with the Price and Availability Assistant. If you'd like to drag and drop a spreadsheet, remember to drag and drop an XLS, XLSX, CSV, or TXT spreadsheet onto the blue box. Mouser also provides a template you can use for additional convenience. If you decide to copy and paste your data, there are 2 different formats for copy and paste entries. Remember, only one product can be entered per line. The delimiter should remain consistent and be a pipe, tab, or comma. You cannot include a pipe, tab, or comma in any part numbers. Both manufacturer and Mouser part numbers are acceptable. Customer part numbers are also acceptable, but must be less than 22 characters. If you do not specify a quantity, it will be defaulted to 1. Lastly, you may decide to enter your data manually. In that case, you can input your respective info in each of the following fields. And get started with your Price and Availability Assistant today by visiting Mouser's website.
We are connected by more than commerce. Your ingenuity, your passion to create is helping drive our growth. And the technological advancements you've either designed or inspired are fast becoming integral components in the automation of Mouser's logistical operations. Sensing, motor control, mobile scanning, IoT, machine learning, robotics. All technologies you, the engineer, have designed, we use in our global distribution center to stock more products, consolidate more orders more accurately, and ship faster than ever. So thank you for all that you do and for developing all the innovations that allow us to continue to better serve your needs.
A future where your mind controls machines without lifting a finger. That's the promise of Brain-Computer Interface Technology, or BCI, which transforms how computers connect with the human mind. Today, BCIs help restore mobility to patients with paralysis or need prosthetics, communication to the silent, and are mapping new ways for humans and machines to interact. Researchers are developing neural technology that translate brain signals into digital commands that allow users to control robotic limbs, type on virtual keyboards, or even convey emotion through devices. BCIs also enable other breakthroughs. The combination of advances in AI, wearable devices, and sensor technology redefine human-machine interaction. Imagine immersive virtual environments controlled by thought or headsets that let users operate complex systems in real time without ever touching a screen. BCIs can reshape industries, from gaming and education to transportation and industrial settings, revolutionizing how humans interact with the world, where thought powers action and innovation knows no limits. Brought to you by Mouser Electronics, where it's our mission to empower innovation together. When speed and design flexibility matter most, engineers have more options. They can print. What's possible in the design process. From lightweight agricultural systems to custom medical implants, 3D printing offers production-grade components, built with precision and on demand. No mold, no waste, no delay. Engineers can choose from advanced materials, titanium, carbon fiber, innovative resins, and high-performance polymers to reduce weight, optimize strength, and streamline assembly. It's more than an evolution in manufacturing. It reshapes logistics, improves sustainability, and enables new levels of performance across industries. It shifts the ways engineers create, iterate, and deliver first to market in today's competitive environment. 3D printing enables more complex designs, lighter products, and flexible manufacturing. Where progress accelerates, innovation can scale with ease, and production meets possibility, building a smarter, more sustainable future, layer by layer. Brought to you by Mauser Electronics, where it's our mission to empower innovation together. Engineering AI for daily life means designing systems people trust that respect privacy, adapt intelligently, and keep humans in control. From responsive smart homes to wearables to personal assistants, iterative use helps AI systems learn. Technology evolves by anticipating needs because engineers design them with the future in mind. Brought to you by Mauser, empowering innovation together. Humanoid robots have moved from sci-fi into the real world with potential for everyday use. But to fully function in the world, a few engineering hurdles remain. Real-time perception, edge AI processing, and high-density power, to name a few. Creating that delicate balance between tech advancement and safe human interaction. It's the combined integration of sensing, control, and computation designed to operate in the human world. Brought to you by Mauser, empowering innovation together.
Quoting can be one of the longest portions of your day. Entering each part manually, along with needed quantity, specs, and other considerations, consumes so much time. Fortunately, there are solutions available to get some time back and increase your productivity. With API Search, your information is integrated from your system and saved for quicker and reliable access to your data. API Ordering. Typically, when you order through the Mauser website, you might experience some human error and enter the incorrect part numbers or quantity needed. With API ordering, the system remembers your previous order history and streamlines the process. So, what perks come along with automation? No more manual entry. You'll no longer need to enter orders manually, avoiding additional steps. This means no more checking to make sure specs and data are correct. An API removes the additional stress. No more duplicate orders. If there is more than one buyer on your team, you might find that you've entered the same order without knowing. An API will notify you if an order has been placed. This eliminates any return processes or extra stock hidden in your storage area. No more wasted time. By using an API, your time is cut in half. This means more time to focus on everything else on your to-do list. No more difficult interfaces. The Mauser API is user-friendly, so even if you're new to the industry, the program will be easy to learn. To get started, visit Mauser's API Hub.
When speed and design flexibility matter most, engineers have more options. They can print. 3D printing has moved into industrial scale production. It cuts lead times, eliminates traditional manufacturing constraints, and expands what's possible in the design process. From lightweight agricultural systems to custom medical implants, 3D printing offers production-grade components, built with precision and on demand. No mold, no waste, no delay. Engineers can choose from advanced materials, titanium, carbon fiber, innovative resins, and high-performance polymers to reduce weight, optimize strength, and streamline assembly. It's more than an evolution in manufacturing. It reshapes logistics, improves sustainability, and enables new levels of performance across industries. It shifts the ways engineers create, iterate, and deliver first to market in today's competitive environment. 3D printing enables more complex designs, lighter products, and flexible manufacturing. Where progress accelerates, innovation can scale with ease, and production meets possibility, building a smarter, more sustainable future, layer by layer. Brought to you by Mouser Electronics, where it's our mission to empower innovation together. When speed and design flexibility matter most, engineers have more options. They can print. 3D printing has moved into industrial scale production. It cuts lead times, eliminates traditional manufacturing constraints, and expands what's possible in the design process. From lightweight agricultural systems to custom medical implants, 3D printing offers production-grade components, built with precision and on demand. No mold, no waste, no delay. Engineers can choose from advanced materials, titanium, carbon fiber, innovative resins, and high-performance polymers to reduce weight, optimize strength, and streamline assembly. It's more than an evolution in manufacturing. It reshapes logistics, improves sustainability, and enables new levels of performance across industries. It shifts the ways engineers create, iterate, and deliver first to market in today's competitive environment. 3D printing enables more complex designs, lighter products, and flexible manufacturing. Where progress accelerates, innovation can scale with ease, and production meets possibility, building a smarter, more sustainable future, layer by layer. Brought to you by Mouser Electronics, where it's our mission to empower innovation together. When speed and design flexibility matter most, engineers have more options. They can print. 3D printing has moved into industrial scale production. It cuts lead times, eliminates traditional manufacturing constraints, and expands what's possible in the design process. From lightweight agricultural systems to custom medical implants, 3D printing offers production-grade components, built with precision and on demand. No mold, no waste, no delay. Engineers can choose from advanced materials, titanium, carbon fiber, innovative resins, and high-performance polymers to reduce weight, optimize strength, and streamline assembly. It's more than an evolution in manufacturing. It reshapes logistics, improves sustainability, and enables new levels of performance across industries. It shifts the ways engineers create, iterate, and deliver first to market in today's competitive environment. 3D printing enables more complex designs, lighter products, and flexible manufacturing. Where progress accelerates, innovation can scale with ease, and production meets possibility, building a smarter, more sustainable future, layer by layer. Brought to you by Mouser Electronics, where it's our mission to empower innovation together.
than commerce. Your ingenuity, your passion to create is helping drive our growth. And the technological advancements you've either designed or inspired are fast becoming integral components in the automation of Mauser's logistical operations. Sensing, motor control, mobile scanning, IoT, machine learning, robotics. All technologies you, the engineer, have designed, we use in our global distribution center to stock more products, consolidate more orders more accurately, and ship faster than ever. So thank you for all that you do and for developing all the innovations that allow us to continue to better serve your needs. We are connected.
No matter where you roam, you'll encounter places you can't access. Brave Norway's Arctic temperatures to venture inside the global seed vault, and you'll instantly be turned away. There's also no chance of getting past the guards at Buckingham Palace to dine with the king. While your thirst may be quenched, the Coca-Cola formula will remain a close.
Hi, everyone. I would request everybody to please take your seats. We will begin in another 5 minutes.
And unless you're Japanese royalty, you'll never set eyes on what's inside the Ise Grand Shrine. But when it's time to obtain the widest selection of semiconductors and electronic components for design, Mauser always gives you full, unrestricted access. Let us be your guide in exploring a world full of technology and innovation. No matter where you roam, there are many places in the world where your access is limited. You can't enter the vaults of Fort Knox. You probably won't find Canada's lost lemon mine. You may never lay eyes on the Vatican's secret archives. And the lost city of Z could remain lost forever. But at Mauser, we give you unlimited access to the widest selection of semiconductors and electronic components from well over 1,000 leading brands engineers know and trust. On your quest for technology and innovation, let Mauser be your guide. There are many places.
Clean tech promises a future where energy systems are cleaner, smarter, and more efficient. Cutting-edge innovations improve how we generate, store, and use electricity, pushing the boundaries of what's possible. With the global renewables market projected to reach $1.2 trillion by 2030, we're on the cusp of powering a sustainable world. And engineers are at the forefront of this transformation, developing high-efficiency solar cells that maximize the capture of sunlight, lightweight wind turbine blades to increase power output, and next-generation batteries with more storage and faster charging capabilities. But clean tech isn't just about power. It's about a tightly connected energy ecosystem. Smart grids enable predictive grid balancing, reduce outages, and optimize efficiency, powered by IoT and edge computing. Breakthroughs from high-performance solar panels and energy harvesting technology to carbon capture devices make clean technology more sustainable, scalable, and resilient. A greener future made possible by reducing, reusing, and reimagining technology. Brought to you by Mouser Electronics, where it's our mission to empower innovation together. Clean tech promises a future where energy systems are cleaner, smarter, and more efficient. Cutting-edge innovations improve how we generate, store, and use electricity, pushing the boundaries of what's possible. With the global renewables market projected to reach $1.2 trillion by 2030, we're on the cusp of powering a sustainable world. And engineers are at the forefront of this transformation, developing high-efficiency solar cells that maximize the capture of sunlight, lightweight wind turbine blades to increase power output, and next-generation batteries with more storage and faster charging capabilities. But clean tech isn't just about power. It's about a tightly connected energy ecosystem. Smart grids enable predictive grid balancing, reduce outages, and optimize efficiency, powered by IoT and edge computing. Breakthroughs from high-performance solar panels and energy harvesting technology to carbon capture devices make clean technology more sustainable, scalable, and resilient. A greener future made possible by reducing, reusing, and reimagining technology. Brought to you by Mouser Electronics, where it's our mission to empower innovation together. Clean tech promises a future where energy systems are cleaner, smarter.
Check. Okay. Welcome back, everyone. Hello. Yeah. Welcome back, everyone, and I hope you're feeling all recharged. So let's get back into it. We now have Mr. Banik and Mr. Srinivas from Phoenix Contact, who will share his insights on intelligent connectivity, accelerating the AI hardware revolution. Please welcome him to the stage.
Hello, check, check. Hello, everyone. I believe I'm audible even at the back. So can you raise hand at the back? Okay. So welcome back to this session, even after this break. Myself is Pravir Banik. Here we are going to present on the connectivity part from Phoenix Contact. So we have chosen the part as intelligent connectivity. I would request for maybe 30-40 minutes, if you can sit little bit quietly and it will be easy to connect. So what is Phoenix and what we believe in the future? So it is all about different kind of electrification, then networking and automation. So this is all about the future, what we know, and that's why we have the association for the all electric society. What means that? We'll go through this, and this is to give a view about Phoenix. This is our headquarters in Germany, Hanover, Bloomberg, and right there, one of the four group center of components is Phoenix Contact India. It is in Delhi. Now, what is the core business group of Phoenix? So it is start with, I believe it's visible at the end as well. So for the device connectors, for all kind of device connectivity, then industrial components and electronics, followed by the industry management and automation. These are three core business group in Phoenix. I would request, I think still there are quite people are there in the tea session. My request would be if you can all come and keep little bit quiet, it will be easy to interact. Thank you. So what is device connector? This is all about different kind of connectivity. We'll come through in details later. Then the next vertical is industrial components and electronics. Here, all the products which goes inside cabinet, starting from DIN rail mountable terminal block, then DIN rail itself, then all kind of active components like power supply, surge arrestor, and so on. Then another part is the power reliability, where different kind of surge protection, and of course some power supply and those kind of power component are available in this vertical. Now, for the industry management and automation, here we have all kind of automation components, starting from IOs, PLCs, and some active relays, even some software are also there in this. So we have our cybersecurity solution, we have PLC Next for automation. Now, okay, we have another vertical is e-mobility. Nowadays, it is electric vehicles, the EV. So we have some solutions for electric vehicles or EV. So what we have all kind of charging components, then controllers. So these are some, again, accessories for EV industries. So that solution we have from the EV. So this was an overview about Phoenix, what Phoenix has as different kind of portfolio. Now, here today we have selected the part as connectivity. So let's talk about connectivity, what it is. When we talk about connectivity, ultimately, what for? We all know nowadays AI, artificial intelligence. I would say it is all intelligent. So all device should be intelligent. When we say intelligent device, what does it mean? It should be IoT enabled. It should be a communication device, or it can be a power conditioning devices, and so on, even for GPU or graphics processing units. So when it mentioned device, what exactly it is? What is the basic, or how we can define it? Every device, it should have some input, and then it will be processed, and we'll get the output. This is a very basic for the device. And every input and every output, there should be some termination. Otherwise, we cannot provide the input to the device, or we will not get the desired output at the end. So for all these input and output, there must be some connectivity or connectors. And we must need nowadays the intelligent connectors or connectivity. What does it mean? When we mention intelligent connectivity, then it should be very fast because time is money. Then it should be robust. It should be reliable, secure connection. Of course, there should be different variants. So different devices, different kind of inputs. We should have all kind of possibilities to get the input and for the output termination. And of course, it should be modular. It should be flexible. Then connection technology. Starting from the traditional screw connections, we should have different kind of flexibility in the connections. Like it should be a different kind of spring base, like spring cage or leg spring or push-in, then crimp connections, or maybe the IDC, insulation displacement connections, and so on. So we have all these options as connection technology through our product. Now, it should be mounted on the PCB, because when we say about electronic circuitry, so it basically we understand as PCB, which should be, so the option should be there. It can be mounted with traditional web soldering or SMD or THR, or maybe the SCAD kind of, or edge connections. Another important thing is connections for ingress protection. What it is? Probably if it is inside the device, IP20 is fine. What does it mean, IP20? 20 means 2 denotes for the solid part, and it should be 12 mm or more than that. So what exactly in practically? If we see our fingertips, it is more or less 12 mm and more. So it should be finger touch proof, and 0 denotes there is no protection against water or water source. But there is some connectivity required at the field side. It should be IP65 or 7 or more. What does it mean? 6 means it should be, there should not be any entrance of solid part which is in the form of dust. And 7 denotes it should be protected against water. How? There is certain limits are there. It should be maybe in between 15 centimeter to 1 meter, and the duration would be 30 minutes. So until that depth and duration, water should not pour into the product, means the connector. So based on the application, we have all those variants. Now, when we see, say, connectivity, it should be either data or power or signal. And for our all PCB-based solution, the brand name is Combicon. That is from Phoenix. Here, it is, when we connect any device, so there will be some rating. And based on the rating, there should be some cross-section. And the pitch, creepage, all interrelated. More we go for the higher rating, the cross-section should be more, and definitely there should be higher rating of connector. So we have all the ranges, starting from 2 ampere and so on, up to 300 and 400 ampere solution we have. The connections, see, we have the very new push-in technology. we have this series, SPD series. Here you just push and connection is made. Then we have the pluggable side. So again, in the termination, it should be fixed type and the pluggable type. In the fixed type, we have SPT range, then we have pluggable side, FKMCP series, and so on. These are some terminology with Phoenix, but for all of us here, what we should carry out, we have the solution, whether it is a push-in spring or the lever operated or Telex kind of technology or the IDC. We have different variants. So we believe one of the solution will be suitable for the application we have. This is a very new connector, Connexis. So nowadays it should be a very fast production. For the serial production, there should be very fast assembly and production. So this is a product which comes with cream as well as push-in. And it comes inbuilt coding. So that means the polarity mismatch is protected, already ensured through this coding. And different ranges are there and different rows. So based on the need of termination or the contacts, so we can choose the product. So how it works or what's the variant? So you can have a look.
Use PCB connectors from the Connexis series for the factory cabling of your machines and
Little bit
devices.
sound.
The items are available in various pitches and designs, with push-in connection, or optimized for automated wiring with tin-plated crimp contacts. The coded connectors guarantee safe and error-free mounting and can be custom printed. Benefit from easier device development with design-in support or use pre-assembled cables for time-saving production.
So whether it is push-in or crimp or serial production, so both options are there. Now, nowadays for IoT or IIoT, so there's devices and which should be very compact and multiple PCBs inside that compact device are used or designed. So for that we have fine pitch connectors which starts from 0.65 and up to 1.27. So for compact devices for multiple PCB in the same device to connect, we have all these options. So how it works?
Board-to-board
Suppose
connectors
this is
with
a IoT
0.8
device
pitch are your robust solution that's
multiple
suitable for
PCB, how to
industrial
connect.
application and
It
reliably
helps.
connects several PCBs in the device. The double-sided ScaleX contact system
is a very
ensures
specific
reliable
technology
mechanical and electrical
which
connections.
ensures
You
robust
can
and
reach data
reliable
rates
connectivity.
up to 52 gigabits per second.
With the same product, we can
With a
use
closed shielding
for
concept,
data
you achieve
transmission.
excellent EMC characteristics. Besides the unshielded variant with external, inspectable soldering contacts, you can also choose the SL version with a smaller footprint, which is compatible with the shielded version for maximum flexibility in your design. The special housing geometry prevents accidental damage to the contacts. With its high tolerance compensation during mating and in the mated
tolerance
state,
is one
FP
very useful
0.8 is a
features
space-saving
while
alternative
these are
to
the
floating connectors.
connection level to mate the male-female
Various
part.
designs provide for variable stack heights with high mating
It helps
security.
the height to adjust. Different
Give your device a flexible design
height
with the
sizes
extensive
available.
FP 0.8 series portfolio of shielded and unshielded variants with vertical and horizontal mating partners.
This is another one. As we mentioned, the connector should be very intelligent, means it should be very fast and quick operation. This is a product while we just touch the conductor at the end, the entry of the connector, you will hear a click sound. So that ensures it is connected. And with visual, also you can see that the lever has lifted up. So when at the side, so when it is connected, you hear a click sound, and also you can see the lever is uplifted. So it ensures the connection is securely made and very easy to disconnect, whether it is for the preventive maintenance or for breakdown maintenance. So we have at the moment these two series, which is up to 1.5 and another one is up to 2.5 mm square connectivity, and which ensures 300 volts and 16 amperes. We have our sample station here, so you can come and have a look at the product. So it shows all the different features of the connection technology, whether it is a fast connection or with some flange for the retainer locking, additional locking systems. So all the benefits have been incorporated in one product, and that is our XPC series. So all the features are mentioned here. Now, the SPT range, which basically for any kind of quick termination, again, you can see the variants are there, different color variants or the orientation. So these options are available. Starting from the miniature, starting from 1.5 mm square cable connection up to we have 35 mm square. So whether it is for the control or signal kind of connectivity up to power. So all the options are available. Lever operation. So it is another, particularly on the when it is for the power connections, it's easy for connection or disconnection. Particularly with this kind of connection solutions, the user is independent whether it can be a solid connector, solid cable or flexible cable, or with lugs or without lugs. So with this kind of lever operation, it's very easy to connect and disconnect. Again, we have different ranges, starting from 2.5 up to 16 mm square cable connections with this portfolio is possible. So that was on the fixed or the one-piece solution. Here we have the same technology for the pluggable or the male-female connectivity.
Lever-actuated PCB terminal blocks and
gives the-
PCB connectors
how
are
it
your
provides the
solution for the
benefits.
time-saving connection of your devices in the field. Open the terminal points, insert the conductors, and then close the levers. Distinct lever positions give a reliable feedback whether terminal blocks are open or closed. The
So very quick and easy installation and operation. This twin design, as it name itself suggests, twin, in the same footprint, we can use either screw connection technology or spring connections. Generally, in the industry application, if it is a screw-based termination, the footprint is different than the footprint of the spring-based termination. But this is the only product I would say in the market at the moment. If it is designed with screw connection technology terminal block, the same can be used for the spring-based. And here it comes again, control from control to power. So it's possible in the same footprint, we can use it. So that was for different kind of connection technology. When we have the circuitry, we have the termination, and now to house or cover that circuitry, we need some enclosure. So from Phoenix, we have different kind of enclosure solutions as well. It can be for cabinet kind of application, like enclosures for different kind of rail mounted devices, like power supply or relay or timer or so on. At the same time, if there is some field application devices, like some tracker or maybe some solar application specific, which is very much in the outside. So there we need protection against dust as well as from water source. So we have all the options, whether it is for the inside cabinet device or outside the field. These are the different range, starting from different kind of mounting base up to enclosures for different kind of controller. So I'm going a little bit quickly. So it gives an impression, the wide and vast product portfolio that we have. So any requirement, any device you are designing, just let us know. Probably you will find one of the suitable solution from Phoenix portfolio. These are some products for field application, field devices with IP. So you can see whether it is for the extreme weather condition or maybe from dust. So all the protections are there. Another portfolio we have, so far we have discussed mostly IP20 kind of solutions and the enclosures for that with IP20 and IP65 and more. There are certain connectors required for IP65 and more for the field connectivity, where we need the protection against not only dust, even against water. So here we have different portfolio. For the data application. So data, nowadays we should not describe or discuss about data, what is data. So we all know about data is the lifeline. So for data connectivity, we have starting from the traditional jack and up to different kind of DSAP connector, or we have USB, then we have connector as well as the patch cable. So whether if we know the length to connect, so we can support you with patch cable. If the length is not known, then we can support you with the connector, which can be connected at the site location. This is one unique product, I would say, which is very fast and very easy to connect.
Realize up to 10 gigabit per second Ethernet cables quickly and conveniently with the IDC displacement connection.
Insert the wire and press down the lever and connection is made. So you can imagine at the site when you are connecting, so easy and so quick and reliable. Then single pair Ethernet. So that is a very new trend where generally for the Ethernet we need 4 pair, but this is a single pair in some of the application. So we have the solution for single pair Ethernet as well. So again, up to 1 Gbps it can be supportive. Now, those were data for the copper range. We have a good portfolio for the fiber optics as well. Again, the connector, or if we need, we know the length, then we have patch cord fiber optics patch cord, or the LIU, light interface unit, or the splice box. So we have all the solution, and the unique one is this single mountable, rail mountable patch panel. So there we can connect as even a single Ethernet or maybe fiber optic. Then we have SFP or the trans receiver, the shell. Of course, from other product groups, we have SFP connector as well.
Compact and yet
What is the
spacious,
features of
the
our
DIN rail splice box for
LIC
reliable
or
fiberglass
LIU, sorry,
connections.
and
Comprehensively
the splice
tested
box.
components ensure permanent trouble-free function and data transmission.
The most important thing
Reduce
is the
installment
splicing,
time thanks to
because
pre-assembled,
if
ready-to-splice design.
splicing is
The
not done
ideally
correctly,
dimensioned fiber
there will be
retainer
loss, there's a
provides
chance of
sufficient space and
data or
ensures
signal loss.
defined bend radii. The compact housing for up to 12 duplex front connections can be attached flexibly, thanks to the wide variety of mounting options available with the DIN rail adapter.
So FDX20 is the series from Phoenix, which supports with light interface unit product or the splice box. The new business trend is for energy storage. In the earlier presentation also, earlier presenter mentioned the energy storage. So we have, when we mention energy storage, basically it is for the battery energy storage or the BESS. And we have dedicated product for that particular application. Whether it is for a battery to battery with the connection with the cable, or if it is higher rated, maybe for 200 or beyond 250 ampere, the busbar systems are used. So we have dedicated products for this kind of busbar termination. Again, very application specific product. Renewable energy, when we mentioned, so solar energy is very much prominent. So we have again this dedicated product. What is the features of this particular product? It's very easy. Again, 3 steps you can connect it. Any one. Otherwise, it is a crimping. Crimping means you need components separately because the crimp contact, then the plastic part, then crimp plier, and of course, that plier, the operator should be very skilled so that he knows for which crimp contact size, which wire to connect, and how to use the crimping plier. All those limitations are eliminated here. You insert the wire, press down the lever, and it's done. It is so quick, in very easy 3 steps, it can be connected. Now, circular. When we talk about IP65 and more, so definitely, and the compact, that definitely comes with circular kind of termination. So we have, for the control side or the signal side, M5 to M12, and for the power side, starting from M17, we have up to M58. And different coding. Coding is for the different kind of portfolio to support application specific. Here to give you again some impression, what are the ranges we have to cover the different kind of requirement. So starting from 20 ampere and up to 70 amps. So this is the complete variant, and even different shape and size, and different cable can be connected from different angle or direction. So we have all those variants. This is one very specific product for field application, field installation. Generally, when we install some device or system, we need connectivity from one instrument to another instrument at the field, or maybe one system to another system. So we have this particular portfolio which can support with either traditional screw termination, or maybe IDC type, or maybe crimp type. So one of the solution, it can be suitable for the application you are looking for. So again, this is the ranges and the ratings available in different series. The name itself suggests heavy duty connector. There is certain application in the industry where we need to execute either for the data or power or the signal, But at the same time, the connector should be very much robust, like if it is in the application of some intralogistic industry or application, or maybe in the railways industries, if you're designing some device for loco. So there we need certain kind of robust connection. For that, to meet those kind of requirement, we have this particular range. Again, different series are available, different variants are available based on the requirement. So we have standard or advanced. So it covers any one of the requirement which you are looking for. Now I would like, yes, Shini come. Maybe he will go through. So what we have just discussed, the portfolio. So how to believe that this portfolio works? So my colleague Shini, he will explain. He's the core guy which implement all those portfolio with different application and different customers. Yes, Shini, what to you?
Thanks. Check. Hello. So here we show a couple of success stories where we have success so far, and whatever the product you have seen so far, how it will be adopted to the existing systems, how it will be used in the your own area of the devices. So we have some references in the CNC machines where you can use the connectors for the multiple layers and all. Some success reference only for your ready-made solutions. In the data center applications, how we can use Phoenix products. So we are showing some reference stories. So especially in the cooling systems, so Phoenix having the product portfolio of power connectors and data connectors, where it can be used especially for the power and data input and output applications. So there's some certain images which we shown there is for the reference purpose. And again, for the GPU unit and the cloud units, so there are IP67 rated connectors are required. So these IP rated connectors are very much essential for the field applications and field usages. So some references and USPs, why all these products are being used, how user friendly is our products. That's what we are trying to show here. Yeah. And data, again, as I mentioned, so data, we have RJ45 tool-free connectors, which can be easily usable at the field. Usually what happens, RJ45 in the field is very tough to crimp, and you have to carry the crimping tools, and maybe if the crimping is not perfect, so the RJ45 has to cut off and use the other one. But in our products, these are especially meant for the field applications, where you can reuse it for 10 times to achieve the 10 Gbps data rates. So these are tool-free connectors. No need to carry any tools at the field. You just have to put the cables and just press it so it gets connected. So that is how the specialty of these connectors. And housings. So for the application like DC-DC converters, every PCB requires a housing or any enclosure. So you just can't place the PCB anywhere on the surface or anywhere on the wall. So you require devices for that. So we have the devices and some references of the device, how it will be connected. And these are customizable along with whatever the electronics what you have, that could be DSUB or any antenna. So all these can be customized according to your designs. So some of the board-to-board applications which we already mentioned. So in the board-to-board applications, you required data transmission more than 30-40 Gbps. So usually what happens, you will have the FRC cables coming from one board to the other board. So instead of that, our board-to-board connectors are high-density connectors, which are EMC protected. You can transmit the data up to 52 Gbps from one board to the another board in all the directions. And these are very high tolerance connectors. So what happens when there's a board on the bottom and there's a board on the top, you cannot see how it is getting connected. So you require the tolerance level. So these are the high tolerance leveled data connectors for the board to board. So for the power, when it comes to the power, so you require the easy connection. It's all every connection has to be easy. So we have push-in technology where it can be mounted and where it can be used for the easy wiring applications. So some connectors and how it will be used in the field inside the devices. These are some references about it. So in the housings, you also require the housings for the field transceivers or any antennas to be used in the field. So for those electronics, so the housings are available with us, which is IP69K protected and also ATEX protected, which can be used in the harsh environment. So these are the examples we are shown how it will be connected on and how user friendly all these things. And again, the housings for the in-house, inside the box. So these housings are modular housings. So again, what happens when there's a housing we mentioned, it has to be customized. Customization takes place. Customization, again, you have to punch it and give it for some third party for the additional punching and customization. So we have another housing which can be modular, where you can configure on yourself where what has to come, RJ45 antenna, some D-sub. So all these can be configured based on your requirement. No additional customization is required. So that's the beauty of these housings. And some housings for the PLCs. So you have your own PLC, you have your own controller, IO modules. Again, for IO modules, you require more number of connections, connectors, and other things. So our housings can be capable up to 48 input and output connections. So in the EV wall box, everybody, we have a lot of EV vehicles, EV cars, and everywhere. So all these EV applications requires power and data connectors. So how the power and data connectors from the Phoenix contact can be used. So there are some examples. So in the especially in the interface modules, so you require high-speed data connectors to transmit what is the data going. This has to be again given information to the cloud. So these are the products can be used in the EV charging controller boxes.
So that was the portfolio with some cases. So we believe when there is some device, so there is some connectivity, and when it is connectivity, it should be either signal or data or power. So there is a statement: when power flows, data speaks and signals control. So we believe with Phoenix portfolio, we can fulfill all this requirement. Thank you.
Thanks, everyone.
I think there is no time for questions. Okay.
Thank you so much, Mr. Banik and Mr. Srinivas. I'm sure a lot of engineers present here would like to connect with you afterwards. Up next, may I invite Ms. Anju from ADI to the stage, please?
So am I audible to everyone? Yeah. Today I'll be talking about one of our solution, coolant distribution manifold for data centers. So myself, Anju, I am from Analog Devices. I'm a field application engineer at Analog Devices. So today for this session, I'll be covering all of these topics. First, we will see what is the data center trend on thermal management. Then we will see what are the main challenges faced by data centers for the thermal management. So there we will be focusing on what are the existing cooling technology limitations. Then we will see how liquid cooling will be more advantage than the already existing air cooling systems. Then I'll be talking about coolant distribution unit. This is one of the main part of the liquid cooling system in data centers. Then we will see what are the different types of coolant distributions unit available. Then we will move to the manifold. Manifold is the headers which will be distributing coolant from the CDU to different racks or rack units in the data center. Then we will see ADI solution. We are proposing a solution called coolant distribution manifold controller, which will be sitting on the manifold and will be controlling, sensing, monitoring the condition of that overall system. So we will see what is a CDM system, a overview. Then we'll move to the controller board description, like what are the different components sitting on that particular controller board. Then finally, we will look into different application other than data center, in which all cooling systems we can utilize this particular controller. So this is just to show a trend, what we are seeing in the typical rack density in the upcoming and already existing data centers. So from starting 2005 to 2012 time period, we were seeing a typical rack density of around 3 to 5 kilowatt. So normal traditional air cooling system was good enough to control that whatever thermal heat was generated by that particular system. So we were using raised flow systems or crack units like computer room air conditioning systems. Then after 2013 to 18 period, we were seeing almost that rack density got doubled from 3 to 5 kilowatt to 5 to 10 kilowatt. So there we need a more efficient solution. So we moved to this hot tail to cold tail condition. So there also we were using air conditioning only, but there we were giving two separate paths for both hot air and also cold air. So it was giving a more efficient solution here. Then again by 19 to 22, the rack density again moved to 10 to 25 kilowatt. So we were like efficiency and power consumption was a very common issue in the systems. So we moved to economization. It's like normal outside environment air was used to cool the whatever hot coolant was flowing. Then by after 2013, by the involvement of AI technologies, the rack density was increasing rapidly, around 40 to 120 kilowatt. So we can see that normal air cooling system may not be able to handle this much high heat generated by this latest hyperscale data centers. So we have to move from air cooling systems to liquid cooling systems. So there comes the role of technologies like sensors, different signal chain components provided by analog devices. So as you can see, that NVIDIA roadmap was showing around, like they are moving from that 40 kilowatt system to around 1 megawatt system, like Feynman systems. So ultimately, I'm trying to say that we need a proper liquid cooling system to control or cool the that upcoming high-end data centers. So these are some of the main challenges faced by the data centers in the aspect of thermal management. So first one is scaling. As I was telling, that air cooling system require huge chillers and also different set of fans. So scaling that existing system for upcoming that 100 plus kilowatt data centers will be very difficult. That either we have to we have to sacrifice on the performance side or the energy consumption side. Second one is energy consumption. So as shown in that pie diagram, almost 35% of the total power consumption of a data center is utilized for cooling system. So if you want to expand the cooling system, again, it means that power consumption by that particular cooling system will be increased. Almost it may go up to 50 to 50%. That IT equipment may consuming almost 50%. Again, the cooling system may also be consuming 50%. So that is not an acceptable condition. So we have to limit the power consumption by the cooling system. So it's like instead of using fans and chillers, we can move to the liquid cooling, and it will reduce or restrict the power consumption used by the cooling systems. Last one is maintenance. As you can see, I have just added one news report there that CME was down for almost 10 hours due to a data center failure. The main issue behind that failure was a chiller was not working properly. So what I mean to say, we have to monitor the systems in the data center, that particular cooling system, so that we will be able to monitor and control the system, so it is not going to a downtime condition. It will be always in the run condition. So these are the different limitations. I have already discussed them, like chillers and many fans are required. So this can generate noise and it can use more energy than what is required. Then also the power consumption. This is also making a main issue here. And other one is like existing air cooling may not be able to control that high heat generated by the upcoming data centers. So this slide shows that water is a more promising solution than air based on different properties like density wise, like what is the heat can be removed by the unit volume of air and what is the heat can be removed by unit volume of water. That comparison clearly shows water takes more heat out compared to air systems. Then specific heat capacity is also better for water, and thermal conductivity, the removal of heat from the surface, that is also comparatively water gives a more promising solution. So we can see that on the basis of thermal conductivity, water is 25 times better than the normal air system. Similarly, for cooling, it is giving 100 times more than cooling compared to air system. On the transport energy, the required energy to transport the heat from the data center system to outside, that is very less on the case of water compared to air cooling systems. So basically, I was trying to show that like for the upcoming hyperscale data centers, we will not be able to use the already existing air cooling system. We have to move to the liquid cooling system. And now we will see how ADI parts like sensors and signal chain part can be utilized for a more efficient and optimized solution, like in the liquid cooling system. So coolant distribution unit is the main component in the liquid cooling system. You can see, so ideally there will be two loops. One is for rack, where the liquid will be flowing from the CDU to the rack side, and it will be collecting all the heat from different equipments or unit in the rack side. Then it will be sending back that hot water to the CDU system. Similarly, on the primary side, there will be a facility loop. So facility loop is the one which will be transferring that heat, whatever is collected from the rack loop, and will be taken outside. And again, cooled water will be sent back to the CDU system. So for CDU system, we need a isolation. So for example, the condition parameters of the liquid flowing through the rack loop should be perfectly matching. For example, the quality of the water, if there is a condensation chance, that may block the tube in the system, that may lead to the failure of working of the complete system. So ideally, we need a pure water on the rack side and that heat removal on the facility side. So isolation is required. So heat exchangers will be used to transfer that heat from the rack loop to the outside loop. So ideally, they will not be in contact. The both waters will not be in contact. And these are the main components part of the CDU unit. Like pump is required. So for controlling the pump, we may need PWM. For example, if you are using a PWM pump, then we have to control. So we have some PWM controllers like MAX 31790 that can be utilized for this purpose. And also, as I was telling, that rack loop liquid parameters, right? We will not be able to compromise on the liquid parameters on the rack loop side. So we have to continuously monitor the state of that particular liquid using different type of sensors. So we have some flow meter solutions, and also we have some pressure solution that can be directly utilized for these purposes. Similarly, monitoring or control is also a main function of CDU system. So we are also developing into this solenoid drivers. So ideally, we will be using valve there. Either solenoid valve or proportional valve will be used for the systems. So that control can be done using our solutions like solenoid drivers, and 4 to 20 milliamps output can be used to control the particular some 4 to 20 milliamps proportional valve. This is the use of the CDU system. Now we will see what are the different types of CDU systems available. So basically, these are the 6 different CDUs we will be seeing in the market. So one is liquid to liquid CDU. The first 3 is divided on the basis of heat removal. How that heat is being removed from the rack loop to the facility loop. So here you can see liquid to liquid condition. So primary loop and secondary loop will be having liquid only. So using any heat plate, we will be transferring the heat from the rack loop to the facility loop. Similarly, second one is liquid to air CDU. So on the rack side, we will be using liquid, but the facility side will move to the air system. So that heat transfer will be from the liquid side to the air side. Last one is rear door heat exchangers. This is basically used when already existing air cooling system should be made to more efficient on the performance wise. I'll give a more detailed idea here. So here I just want to give an idea on how this liquid to liquid CDU, how the liquid to air CDU will be working. So on the first image, you can see there are 2 loops, primary side and secondary side. Both loop will be having water, liquid only. That liquid will be transferring heat from the secondary rack loop to the primary facility loop. On the right side, we have a combination of liquid to liquid CDU and liquid to air CDU. So on the part of liquid to liquid, we will be using water tower on the facility end, and water to water heat transfer will be utilized. And on the liquid to air side, we will be using a dry cooler. So that water to air heat transfer will be happening. This is the third one, rear door heat exchanger CDU. So here, fan will be used to transfer, or air will be used to transfer heat from the rack side to back side of the rack. And this rear door unit will be sitting on the back side of the server rack, and through that will be flowing liquid from the CDU side. So basically, liquid to liquid is used when you have a system whose power density is greater than 100 kilowatt and maximum efficiency is required. And liquid to air is suggested if there is a scarcity of that facility water availability. Then we can go with the liquid to air condition. And this rear door heat exchanger is utilized, as I have mentioned previously, when there is an existing air-cooled data center is available and you want to expand that system in a optimum performance cooling system. Then we can go with the rear door heat exchangers. Now the second category of CDUs are rack level, row level, and room level. This is basically based on the architecture of the CDU or architecture of that entire data center, like how you are going to place the CDU in the system. So this is an explanation on that one. Like on the rack level CDU, that CDU will be dedicated for a particular rack or a number of rack units. So that will be sitting with the rack unit. On the row level CDU, there will be a row of racks, server racks, and each row will have a dedicated CDU. Then we have the room level CDU also. Means room level means for that entire data center, we'll be using a single CDU, or for a particular rooms, we'll be using a single CDU system. Now we'll see what is manifold in the CDU system. So I was talking about row CDU, right? So for the rack in a row, there will be a dedicated CDU available. So manifold means that it is a header which will be taking liquid from the common CDU and it will be distributing to each rack in that row. So it will be controlling the flow distribution, that fluid flow will be controlled here. Then collection, taking back the hot fluid from the rack level to back to the CDU side. And also flow balancing. Like for example, maybe for a particular rack, the liquid requirement will be more. It may be generating more heat. Then in that case, we have to allow more liquid to flow through that particular rack. That all control will be done by the manifold side. So you can see on the right side, for that 1, 2, 3, total 8 rack is shown there. And that blue line is showing coolant flow, like liquid will be flowing from the CDU side to each rack. And the point from where that rack is getting coolant, right, there will be different type of sensors connected. So we can make it more intelligent. The distribution of the coolant can be made more intelligent. This is a detailed description. So we have actually 2 types of manifold. Row manifold is also available. Rack manifold is available. So we are proposing a solution for row manifold. Particularly for each dedicated row, we'll be having a controller system. And we'll be having dedicated sensors like shown in that image, pressure sensor, temperature sensor, flow meter, and also there will be a dedicated valve also. So now we'll talk about the controller side solution, what we are proposing. Maybe I'll go to the next slide. So this is how it will look like. There will be a pump, common pump, and that will be part of the CDU system, which will be distributing the coolant to each rack. And on the rack side, for example, rack 1, there is a dedicated microcontroller. That say a dedicated CDM controller. That controller will be connected to each sensors connected in that line. For example, we may have flow meter, temperature sensors on the inlet and also on the outlet side. Then pressure sensor on the inlet side. This is basically to monitor the parameters of the liquid, so that whenever there is a mismatch in the liquid parameter, the rest people will be able to identify there is a fault, and we will be able to isolate that part using the proportional valve, and we will be able to maintain it properly. We can reduce the downtime of the system. And also it will help to distribute the coolant on the required manner. For example, my rack 1 is generating higher heat. Then in that sense, more coolant should be flowing to that system compared to all other rack system. Similarly, if the rack heat generating is less, then lesser fluid should be going to that particular rack. So that control will be possible using a CDM controller. Now see what are the key components in the system. So I was telling about temperature sensor. So what is the requirement of temperature sensor? So it will be monitoring the condition of the fluid. So there will be 2 sensors. For example, one in the inlet side and one in the outlet side. So we will be able to calculate the heat load of that system, that particular rack, using the sensor value and also the flow meter. Then using that heat value, we'll be able to maintain the proportional valve opening. For example, it's not a on-off valve, it is a proportional valve. So if you want to open it 50%, 30%, so based on the cooling demand for particular rack, we'll be able to change the opening of the valve also. And pressure sensor, this will be helping to identify any kind of error in the system, whether the fluid is flowing through the pump properly or not. Those monitoring, we can use the pressure sensor. If there is any blockage in between the pipe anywhere, that pressure sensor variation will be able to identify that blockage. Similarly, leakage sensor, it is a very critical part. If the leakage exists, for example, a data center is working for a long time, there could be some heat leakage generating because of some fitting fault or any kind of fault in the system. So those could be early detected. If there is any kind of short leakage itself, we'll be able to identify and we'll be able to maintain that properly. And radiator fan is used for standalone systems to cool down the water. Instead of going to that facility loop, it will be cooled from that standalone system itself. So these are the main features we are showing, like our board size is compact. So it will be able to sit in the in-row system, and there will be real-time monitoring using these different type of sensors. Then we are also providing a single pair Ethernet 10-based EVNL connectivity on the board, so that the values or readings from the temperature sensor and monitoring control can be done from a centralized unit sitting at a distance. It can go up to 1 kilometer. Then IO for different industrial signals. It means there is a software configurable IO connected on the board, so that different type of sensor output, like 4 to 20 milliamps or 0 to 10 volt, that can be directly connected to this controller board, and we'll be able to monitor the status of the fluid. Then we are also providing a embedded real-time operating system support. This will give more reliable data from the system. Uniform cooling will be ensured, and dynamic control of the liquid flow will be ensured here. So this is the controller board overview. This is all different ADI parts, like software configurable IO is there, microcontroller is there, fan controller, then 10-based EVNL, that single pair Ethernet connectivity. Then there is a single pair Ethernet PD also, just to provide the power to the system. So how it is important, this means using that single pair twisted cable, right? We'll be able to power the board. Same time, we will be able to communicate the data also. So these are the different part numbers. We'll check them in detail. So this is how the board will look like. It will have 8 SWIO channels and 6 fan controller. Then that single twisted pair cable connector will be there. That can be connected to the centralized client, and it will be helping for monitoring and also controlling purpose. So software configurable IO means there are, for example, 4 channels. For each IC, there will be 4 channels. So each channel can be configured as analog input, analog output, digital input, digital output, whatever is the requirement based on that one, using pure software. Then the RTD. RTD will be mostly used for industrial applications, especially in data centers and all, for measuring temperature value. So that RTD can be directly interfaced with the software IO part. Then it has a 24-bit ADC, 16-bit DAC, and also inbuilt precision reference is available. And also the excitation required for the RTD will be provided by this particular IC. It has integrated heart also, and there is an adaptive power switching feature included here. This will reduce the power dissipation by 40%. And direct sensor interface or actuator interface is possible. So what I mean to say here is like sensors like RTD can be directly connected to the channel. There is no other signal conditioning or any extra reference, extra excitation. It is not required. You can directly connect it. Actuator means like for the system we are using, if we are using a proportional wall, for example, 4 to 20 milliamps proportional wall, the required current can be given directly from our software configurable IO. How this will be helpful? As I was seeing, most of the industrial pressure sensor output will be either 4 to 20 milliamps or 0 to 10 volt. That can be directly interfaced with our IC. Similarly, RTD can be directly interfaced. So almost all the industrial signals can be directly connected to the controller board. So these are some features of this part which will be helpful for the systems. Next one is fan controller 31790. So fan controller is required for standalone applications, like where the liquid will be cooled at the same system level. It is not going to the facility loop. So 31790 has a 6 PWM fans. So if you are using three channel can be connected to the fan and the speed of the fan can be controlled. So when this is useful, for example, rack 1 has a dedicated fan system and the cooling required for rack 1 is higher. Then in that case, we can run the fan with the full speed and it will be cooled very fast. If you are going for a system which has a cooling demand less than the fan speed, so this will provide an efficient and optimized performance. That power consumption by the cooling system can be maintained. It will not be increased. Next is ADIN 1110. This is the 10 base T1L5, MAC 5. So this is a Ethernet standard and it enables 10 Mbps full duplex communication using single twisted pair cable. It can go up to 1 kilometer. Long reach communication is possible. So if we are keeping each CDM board on for a particular rack, that data can be taken to a centralized unit monitoring part, then you will be able to see if there are any variation on those parts. So ADIN 1110 is a integrated MAC 5. So a separate MCU including 5 is not required here. We can directly interface with the MCU using SPI and it provides optimized solution for low power nodes and also support robust and long reach industrial Ethernet communication. So these are the main advantages of adding 10 base T1L communication on the board. Like it provides long reach connectivity. So it needs only single pair Ethernet. So it will reduce the cable bulk, cable cost and also installation cost. It provides direct Ethernet to sensor connectivity. There is no need of gateway or repeaters in between. You can take the signals directly up to 1 kilometer. Then it provides a robust industrial communication. Next is LTC 9111. This is a single pair Ethernet PD power delivering part. So using this one, we'll be able to power the controller board. There is no need of separate power rails to power the controller board sitting there. And so this is how that system will look like. I already explained this one. So basically, we are providing a controller board for a cooling system. This can be used for data center application for in-row systems. Other than that, this can be used for other similar applications also. So like fast charging station is also moving from air cooling to liquid cooling. So this is also a relevant application. Similarly, railway system is also looking for cooling solutions. So we can propose the solution there also. For ESS, energy storage system or BMS system is also moving to liquid cooling. Similarly, radar. On radar also, it was using air cooling system. So this big box kind of thing is a cooling system only. So now they are also moving to liquid cooling. System level tester is also producing high amount of heat. There also we will be able to propose these type of solutions. So our idea is like ADI product is also relevant in the data center connectivity or controlling unit. We also have other solenoid drivers, pressure sensor AFEs and flow meters and obviously power solutions for rack to chip level power solutions. Yeah, that's it. Thank you.
Thank you so much, Ms. Anju. For our final session of the day, please welcome Gavin Pereira and Sahadev Devangi from TE Connectivity, presenting on powering human-like intelligence.
Hello, am I audible? Yeah, thank you. So good afternoon, everyone, and it's great to be here and see all of you all present over here. I'll not take too much of time because I know lunch is already served. We are probably beyond the lunch time, and let's get on with it and uh, complete it as soon as possible. So first, I will take you through a short corporate overview of TE, followed by what TE is doing for artificial intelligence and data centers, and then my colleague Sade will take you through the certain components which are for these applications. So TE, the main purpose is to create a safer, sustainable, productive, and connected future. And we are focusing on 4 mega trends: enabling communication networks, making factories and homes smarter, innovating energy networks, and advancing the future of transportation. TE is a multi-billion-dollar company, and as we have closed last year with $17 billion in sales. Our sales, you can see, are spread equally across the globe. We are divided into 2 major segments: industrial solution segment and transportation solution segment. And we have multiple BUs under these segments, under which we offer a variety of products. The product categories mainly fall under connectors, sensors, tubings, sealing and protection solutions, relays, application tooling, EMI and EMC solutions, and wires and cables. So we have over 110 manufacturing plants globally and over 80,000 employees. We are one of the world's most innovative companies. We spend about 5% of our turnover on R&D, so about $830 million last year. We also have 10,000 R&D engineers, out of which 1,000 plus are based out of India. So we have repeatedly been awarded as one of the most innovative companies in the world. We are very much focused on sustainability, and we have taken various initiatives to reduce our impact to the environment and also enabling social causes. So that's a short corporate overview. Now coming to what we do for artificial intelligence and data centers. So one of the applications which we look at when you talk about artificial intelligence is humanoid robots. So it is at a very early stage, I would say, in India. Maybe other markets are progressing much quicker than in India. But I think at the recent AI Data Center Summit, we did see a lot of talk around the humanoids. So that's one of the topics we are talking about today. So what is enabling or leading to a growth in humanoids is the labor issues and certain efficiency requirements. For example, in e-commerce, applications like picking and sorting, this calls for a lot of repetitive tasks which have to be done efficiently and quickly. So that is one of the major reasons driving humanoid robots. And what does T support over here? So one is we are offering variety of communication, connectors, because you can imagine that in a humanoid robot there are various the central CPU, the actuators, sensors which need to be connected with each other, and they have to communicate with each other. So the cabling and communication solutions. Of course, when you talk about humanoid robots, it calls for a lot of sensing. So that is another product line which TE focuses on, and also we are focusing on the charging side. So some of these humanoid robots have to be charged automatic charging, and we work on that part of it also. So coming to the so this slide is basically telling you that application wise or sub application wise in humanoid robots what T is offering. So we have divided a humanoid robot into the sensing and communication subsystems, domain controller, power system, and end actuators. And the components which we offer go from the PCB connectors, communications, power, relays and contactors, filters or EMI filters, and sensors, as well as antennas. So we have a wide basket offering to humanoid robots. So this is again going deeper. So if you take, for example, the sensor and interface PCB, TE offers the mini IO, single pair Ethernet, mini bridge, micro bridge. So we'll go to more details about these products when my colleague takes over. And FAKRA connectors. Then we have also RJ45 type of connectors, M8, M12, cord sets, and antennas. Then when you come to the domain controller system, again, it is more high speed kind of connectors, IDC type of connectors, and again, the M8, M12 cord sets, which we offer. And then when we talk about the power system, here is where our charging connectors, which are the HK2, blind mating charging, HMN floating, DPSC. So depending on the way, whether it's automatic charging, manual charging, stackable kind of charging, different types of offerings based on these applications. And finally, we talk about the sensor or the end actuators. Again, here we offer both sensors as well as the connectors. So you can see a variety of connector offerings for the end actuators. And also we have sensors like the torque sensor, which is in our portfolio. Coming to the data center application. So here what I'm going to take you through is more on the the gray space, as they call it. So as a data center is divided into the white space where the actual servers and storage systems are happening. Here I'm focusing more on the gray space, which is the power solutions and the cooling solutions. So when we look at a data center architecture today, you have the switch gear, transformer, the low voltage switch gear, and then coming to the power section. So Gen 1, in the Generation 1 architecture, you'll have a UPS, power distribution unit, rack panel with a PDU and PSU. And that is now kind of in Gen 2 getting replaced with a busway kind of architecture, and the power is moving into the sidecar power rack. So for this, architectures, what we are, offering are filters, the active harmonic filters in our portfolio, EMI and EMC chokes, DC contactors. So when you talk about data center, it calls for very quick switching and much higher charging currents. So TE has a very strong offering with such type of contactors, and we are also building our portfolio to enable even quicker switching, which is a requirement of data centers. Uh, Again, we have relays. So TE is one of the leaders in relays, and we have a wide portfolio of relays, power relays, PCB power relays we call it, or we can have even signal relays and panel mountable relays. We also have heavy duty connectors which are required for connecting between the busway and the sidecar panels. Sometimes they're also called as the roof mounted connectors. And then we have the distribution blocks in our portfolio, which is used for basically, it works as a splitter or a combiner of cables. The other application where I'm talking is the cooling distribution units. Again, T is offering the electrical components for the coolant distribution units. So whether it's the liquid cooling or air cooling, we have offering of filters, contactors, and heavy-duty connectors, along with the M8 and M12 cord sets, which are basically the communication patch cords. So I'll now hand over to my colleague to just take you through in details of certain products. So over to you, Sadev. Thank you.
Thank you. Thank you. Thanks, Kevin. So I'll be taking you through the sub component level products that TE manufactures for the applications and sub applications that Gavin took you through. So these are some connectivity solutions that we have. Uh, Unsealed connectors, wire to board, different types of connectors are available based on different central line needs. And we also have certain connectors with TPA feature, terminal position assurance. And there are connectors here that are capable of handling in a very rugged, vibration prone environment. Basically, the humanoids has very moving element, and there are chances of disconnection. So that's why we have a special technology called as 3-point technology from the dynamic series of connectors, which can cater to that particular environment. And we have some legacy connectors in different center lines like 2.54, 1.27 center lines, and microbridge connectors as well, available in both the crimp as well as IDC kind of connections. And we have few more connectors here. We have dedicated FPC and FFC connectors. So basically, some of these connectors are used to connect the individual fuel cells to a particular BMS and other such kind of applications. And we also have Ampax rated for very high power requirements of 32 amps with 5.7 pitch. And there are few IP rated up to 67 IP rating can also be achieved using these connectors. And we have some communication connectors here. Industry standard M8, M12 decoded and excoded is what we are seeing that are being used in the humanoid application. And we have industrial IP20, we call it mini IO. Basically, this works as a typical RJ45, but this is for an industrial use, meaning these are very rugged connectors, has a minimum pull strength needed to disconnect, and it is also smaller, 4 times smaller than a traditional RJ45. So the interface of this is 4 times smaller than a traditional RJ45. So whenever there is a miniaturization need, this is something that can be proposed. And more on the M8 M12 connectors. Single pair Ethernet is a new design that is coming up. So for any less speed connection for, let's say, 1 Gbps speed, there's no need for 4 pairs of wires. Just a pair of wire would be more than sufficient. This kinds of give more flexibility and also reduces the cost of the connector. We also have cord sets, meaning we have catalog products as well with defined length, and we also undertake custom cable assemblies as well. And more on communication connectors, USB connectors. So we have both Type C with latch as well as Type A connectors. And floating connectors, basically for connecting in the PCI Gen 4 kind of protocols. And these come with a floating design. So these come with tolerances. Basically, these are board-to-board type of connectors. And board-to-board, you have very less accessibility or visibility of whether they are mating or not. That's when these tolerances will help you the mating of these those two connectors. And a few more speed connectors from the line. And we have SMC, again board to board, comes with the different types of tolerance as well as angular tolerance for easy mating of these connectors. And moving to the docking or blind mating connector, these are basically used when the robot, once it is out of charge, it goes to the charging charging station, and it docks itself to the charging infrastructure and docks out. So for those, you need modular connectors. You need signal as well as power, and these are available within one modular connectors. And these also come with tolerances because the robot itself will dock to the charging inlet and dock out when the charging is done. It comes with a good number of tolerance here as well. Plus or minus 15 X and Y axis tolerance is available. And these are battery stackable connectors. When there are more battery racks and you need to stack each battery one on top of the other, these are some of the modular connectors available. Both the power and signal applications are all, power and signal connections within the connector. And DC contactors, this was covered a bit earlier. And we have different types of DC contactors rated for 1000 volt DC as well as 1500 volt DC, starting from the current range of 50 amperes until 600 amperes. And we have some power relays as well rated up to 40 amperes. EMI MC Solutions. So T has acquired a company called Schaffner in the recent years, and we also from that have product depth of EMI MCC filters. So we have both single phase filters, DC filters, as well as three phase filters in multiple ranges. And we also have PCB level chokes as well as PCB level filters as well, both single stage and double stage. And finally, we have some sensor element products. Here we are only showing the torque sensors because we covered the humanoid application earlier, and there you have a lot of actuators, gripping movement, and everything where torque sensors are needed. And this is also one of our product. These are some of the success stories where we have pitched in, and this is being used in some of the end customers. Here you can see for the sensing element on the camera, we are providing the mini IO for wire to board connections. And for the actuators, we are giving mini bridge connectors. And for the battery system, basically for swappable battery system, we have a customized battery connector. This is also something that we have. And another humanoid kind of robot, we have successfully spec'd in a few connectors from our end, and a few more communication connectors for connecting different types of communication controller units within a robot. And again, camera system, and one of our type C connectors being used for the camera system, camera module. Yeah, this is the gist of our presentation. We have our some of the samples available. We also have a stall. Please feel free to visit us, and we're looking forward to the discussion. Thank you, everyone.
Thank you so much, Mr. Gavin and Mr. Sahadev. I know it's lunchtime, but please bear with us for some more time. Our next speaker is Mr. Ashwint Raj, an electronics engineer, hardware developer, and technical content creator who enjoys transforming engineering concepts into real-world working systems. Today, in his session, he will walk us through the complete development journey of a vision-assisted robotic assembly built using industrial-grade components sourced through Mouser.com. Thank you.
Yeah. I have to just get rid of this pop-up. Hello, check. So, hi Al. Thank you, Payal, for introducing me and giving me the stage. My name is Ashwant, and I'm here to tell you a very short story. And when I say short, it's really short. I'll keep it brief. I'm going to take you through the journey on how we built a project from a very concept stage to a working prototype, which I believe most people saw during the demo session. And I'll keep it very brief. I'll just discuss our journey on how we started from concept to component selection to how we designed the whole thing and how we got everything to working together. So yeah, the basic idea is we wanted to build a demo project for this very same roadshow, and we wanted to keep it fun and interesting. So we thought, let's build a robotic arm that could assemble a car. So we started by 3D modeling a car with different parts. As you can see, these are the different parts which the robotic arm has to pick up from one side and assemble it on the other side. Now, to do this, we need to do various things. First thing, we have to pick up each of these components individually. So we started by adding a suction pump to this robotic arm that could pick these parts. And then we need to make sure that the parts are present in the right location so that we can fetch the right part at the right time. For that, we added a vision camera. And once we add a camera, we need some kind of edge computing platform to process those images to tell us if it is the right part that the robot is picking up. So we also added edge vision. And to move this robotic arm, we'll need inverse pneumatics to figure out where exactly the part is. So there are various subcomponents that are getting involved in this project. Where I'm going with this is, even for a simple project, even for a simple pick and place project, you would be needing to power the entire system. You would need a compute module. You will need a control module. You will need safety and integration. And very soon, a simple project gets converted into a architecture with multiple subsystems. And this is where having a single stop electronics component distributor like Mouser comes in very handy. In fact, this complete project was built using components purchased from Mouser Electronics. I'll get into details of that. But this is just to give you an overview that even if you're building a holistic system, there will be multiple subcomponents, and it is always good to have a single distributor who can meet all the needs. Okay, so we'll start with enabling the motion. As I told you, the robotic arm has to pick up the parts from one side and assemble it on the other side. Now, what we noticed is the working envelope of the robotic arm is very small. We won't be able to reach all the parts in a very single time. So we have put an X-rail axis. The X-rail axis is used to move the robotic arm along the X-rail so that we'll have a bigger working envelope and we'll be able to reach more parts. And for this X-rail, we have used two important components. One is a stepper motor, and the other is a driver module for driving the stepper motor. The stepper motor is the QSH5718 stepper motor from Analog Devices. It is a dual phase stepper motor, and the motor driver module used to control the stepper motor is from the Trinamic series. People who have used stepper motor should be familiar with this Trinamic series from Analog Devices. So the stepper motor driver module and the stepper motor used to drive the X-axis comes from Analog Devices. I have also put the specifications here for those who are interested. And next thing, we have the X-rail axis. Like I told you, I have to power this entire system. And there are two main systems here. One is the Edge AI compute module, which is an NVIDIA Jetson Nano that you can see sitting inside my control panel over there. And the other is the actuators of the robotic arm, the stepper motors. So I need two different power infrastructure here, one to power the compute module and the other to power the stepper motor. So we have used two AC to DC power converters from Phoenix Contact. Both of them are from the PSEE2G series. One is a 120 watts AC to DC converter, and the other one is a 75 watts AC to DC converter. We have also used a contactor from Phoenix Contact, which is connected to the emergency stop switch over there. So just in case if the robot is getting out of control or it is getting into places it shouldn't, we can use the emergency stop button to stop it. And then once we have the control panel, we'll also need status indicator LEDs, buzzers, and even heat shrink tubes, the crimp connectors. So because it's going to be a complete industrial design, so we'll be needing all those components, and all of that has been procured from Mouser Electronics through TE Connectivity. Like I told you, the push buttons, and you can also see the part numbers of the status LEDs we have used here. All of this is wired using the shrink tubes and the connectors provided from TE Connectivity. And we have also designed a PCB. Even in the previous slide, if you take a look into the control panel box, you can see the PCB inside. So this PCB here is designed to provide a protection and feedback for the complete system. So when the robot moves along the X-axis, we need to figure out a homing position for it. So we have used the magnetic sensor from Little Fuse to figure out the homing location of the robot. And we are also monitoring the temperature of the NVIDIA Jetson Nano inside using a thermistor probe. And then we also have that PCB designed over there, which controls the X-axis stepper motor. And this PCB also has a PPTC fuse as well as a TVS diode to protect all the relay components present on the board. So this is the complete system architecture for the project. We have the main robotic arm, which is a 6 DOF robotic arm sitting on top of X-axis linear motion rail. And we have a vision camera connected to our robotic arm. This camera is connected to the AI edge processing and control module, which is the NVIDIA Jetson Nano. And so basically what happens is the image goes to Jetson Nano. The Jetson Nano figures out if the part is in the right location, and then it gets connected to the motor control module, which operates on ESP32. and it tells us, okay, the part is present here, and with that coordinates, it will calculate using inverse nematics the exact position of all the degrees for the servo motor and figure out where it should go and how to pick that part. Once it picks the part, it will come back to the assembly plate and assemble it. So like I told you, all the components needed to build this project was procured from Mauser Electronics. So this is a photo taken just before we completed the project. For those who don't know, this project is actually sitting there as a live demonstration on the table. And this picture was taken just before we started assembling our robot. You can see the parts that we have purchased from Mauser Electronics before we started assembling. And these are the designs we have made. One is the 3D model. Yeah, another thing I forgot to mention is we have completely 3D modeled this robot and 3D printed all these parts. These days, it's very easy to build complicated systems with the help of 3D printing. So if you can see, the front plate and all the connectors that you see here are 3D printed and put together using parts from 3D printers only. And then we also have a PCB in the middle, and the leftmost image is the control panel. And this is us bringing the project to life. On top, you can see the control panel getting assembled. All the components from Mauser is being assembled inside the control panel. And on the bottom right, you can see the robotic arm being assembled over there by my colleague. So yeah, so once everything is ready, we also have a display over there which shows the live feed from the camera. So in the next slide, I'll be able to show you the working where the robot actually picks the components and assembles the car. But yeah, the complete setup looks like this. We have an assembly rig, we have a control panel, and we have a display which shows the live camera feed, and it shows the component being picked up and assembled in real time. So this is the working video. I have fast forwarded it. But you can see on the top left, the car is getting assembled part by part in sync to the other place where you can see the components being picked in real time. And on the right side, you can see the live feed. The camera feed is detecting the parts. So if you see, it's basing one component, and now it's going to detect the part, and the detected image can be seen on the bottom. So it's going to detect each part and then pick it, bring it to the right place, and assemble the car just like it is shown over here. So yeah, that is it. Basically, I wanted to share how fun and interesting it is when you can bring in multiple different parts and build something interesting that can work and attract a lot of crowd. And that's it for my presentation. Thank you.
Thank you so much, Ashwint. So due to time constraints, we will have to skip the Q&A for the panel discussion. But however, if you have any questions, please do connect with our suppliers here. They will be available to answer all your queries. May I now welcome on stage Clinton. He's the VP of Mauser India. So please welcome Clinton to the stage.
Good afternoon, everyone. My name is Clinton. I'm the Vice President for Global Support. First of all, I just want to take this opportunity to thank each and every one of you for gracing your presence and making it in such large numbers for today's event and making it successful. We're really overwhelmed with the kind of response that we've got. We actually expected about 400 people to come in, but we had 500 plus. So I first of all want to thank all the presenters, the speakers today. I think the presentations were very good, informative, and I'm sure all of us have some good takeaways for the presentations that we had. I also want to thank Payal, Saurabh, and all the Mauser team here for coordinating this event so very well with our media partners, EFY, and our PR partners. So thank you so much. And I just want to tell you all that we're going to be breaking for lunch now. So lunch is going to be served at two counters inside the hall and one counter outside the hall. All right. Thank you so much. Sorry, before you go for lunch, we have few mementos for the speakers. So if you could just bear with us for about for about 5 minutes, and we'll give away the mementos. Kevin, can you please come on stage? We just want to give away some of the mementos. Can we have Mr. Kumar? Can we have Mr. Banik on stage, please?
Check.
Mr. Navneet? Can we have Mr. Navneet on stage, please? Can we have Anju? Can we have Ashwin on stage? Mr. Ashwin? Can we have Mr. Gavin on stage? Mr. Navneet? Mr. Navneet, can we have you on stage, please? Okay. Thank you, Kevin.
We're going to get a marketing group? Okay.